Hello everyone. Welcome to this Certification Days 2020 session. We're going to get started in a couple of minutes. We're due to start at 9 a.m. UK time. So I'm just going to wait a few minutes. I can see loads of people joining. So I'll try and start promptly at 9 o'clock. So I will come back to you then. I hope you guys can hear me. I've just got a thumbs up from my colleague who's listening in. So it's good to know that things like microphones are working. It's always reassuring. Otherwise, I'm going to spend the next 5 hours talking to my screens. So I'll come back to you in about a minute, and then we'll get cracking. Okay, my watch says 9 o'clock, so I think it's time to get started. So once again, greetings Trailblazers, and welcome to this session, Certification Days 2020 session. We've got a little bit of housekeeping to cover before I get stuck in, so I'm just going to go through a couple of slides here. I'll give something a try. Let's see, here we go. So, first of all, this all sounds a bit scary. You're all in listen-only mode. So, when I'm an instructor, so I usually deliver training, I'm used to a bit of interaction, but sadly, it's just me talking here at the moment to you guys. This is just me talking. We don't really give you any sort of org or documentation. These sessions are not recorded, and although I'm going to show you some slides here that there will not be shared. Also, sadly, there will be no Q&A as a result of this. If you do have any questions, sort of operational questions, like you can't hear me, or you can't get onto the webinar, or other disasters happen, then there is a link there, and our operations team will try and help you out. But they won't sort of respond to any content related to questions. The good news is there is going to be a little voucher shared to you, but this will not be at the end of the webinar, so I'm afraid you have to wait until then to get the good news, a cruel and unusual punishment. If you do have questions, the options for you guys are really to go to the community group, what we used to call the Success Community, Trailblazer Community, I think we call it now. So if you go to success.salesforce.com and sign on there, there's a bunch of groups around role, and obviously for us in this session today, it's the Developer Trailblazers group, which would be an appropriate place to post if you do have questions. Bear in mind that this is not moderated by Trailhead Academy. Me and my colleagues who do work for Salesforce occasionally do respond to questions there if we think we can help out, but a lot of the interactions there are you guys helping each other out, which is just amazing. I've always been amazed and impressed by the Salesforce developer ecosystem. It's incredibly supportive and incredibly large. There's also a link to any frequently asked questions about certification days. I'm going to go through some stuff, particularly about the use of the voucher we're going to give you at the end of the session. So we'll hopefully be able to cover any immediate questions you have. But if not, then head over to the FAQ group. Or of course, I'm just going to go back just to show you that slide again. Hit the Developer Trailblazers group in the Success community and the Trailblazer community. So let's see here. I can see a whole bunch of people still joining, so welcome. The cert, the voucher we're going to give you, what it will do, I'll talk a little bit about it now, but I'll reiterate this at the end of the session. It's a voucher code. It'll give you sort of 50% discount on any of the $200 exams. Some of them are more. So if you do the architect designer ones, they're more, and this won't work on those. But for the $200 ones, so things like platform developer one or admin, you don't have to apply it to the cert that's appropriate to the content today. It will work on those. You can do it on up to 3 exams. So basically, you can take the same exam 3 times if you fail, and it works for resits as well. Or you can do it on 3 separate different certifications, as long as they're the $200 jobs. The downside, if you like, is don't hang around too long. You've got to get this thing done by, or rather to take advantage of this discount by the end of July 2020. So I know we're all, if you're like me, I'm talking to you from the UK here today in London, where it's remarkably sunny. We're all in a lockdown state in some shape or form around the world, but the good news is we can take these certs remotely if you need to, and I think we have relaxed some of the onerous restrictions on doing that. So you should have a fair chance of being able to, take up this offer by the end of that date. Okay, so let's see what we got next. I think that's it for the housekeeping. So we are going to get stuck into the content, the meat of the session here. It's going to last for 5 hours. Seems like a long time. What I'll probably do is I'll take a couple of breaks every now and then. I'm certainly going to need them, and I'm sure you will do too. Listening to my voice droning on for 5 hours, it sounds awful. So we'll do that as we go through. So probably about every, 90 minutes or so, whenever we're desperate, we'll take a 10-minute break or something like that, just to give us the option to go get a cup of tea, visit the bathroom, that kind of thing. I'm talking about myself there, I think. So, guys, ladies and gentlemen, this is our topic for today, preparing for your Platform Developer 1 certification. And at the bottom there's me. So I'm an instructor with Trailhead Academy. Trailhead, we are part of the team at Salesforce who bring you Trailhead. The Academy is recording ourselves are the live bits where you get a real person talking to you, as opposed to all the online stuff, which I'm pretty sure you all know or should know about. I've been with the company just over 5 years now, and I deliver developer training. So I focus on things like, well, first of all, the declarative tool set that we can use to build solutions, but also, of course, this thing primarily about Apex. I also look at integrations, the APIs, and Lightning components, both Aura and Lightning Web Component-based programming models. So that's sort of my patch, if you like. And it's a lot of fun. I've been doing this for a while. So it's still weird to be talking to you with no interaction. So I'll carry on and see how we go for the rest of the day. Forward-looking statements. I don't really plan on making very many. This session is more of a review of the sort of thing that we think you might be, tortured on in the certification. Although the certification team is part of Trailhead, they're a separate outfit, and I have really not direct knowledge of exactly what's in these certifications. I have the same information that you guys do, the exam guide. I've taken the test some time ago, I have to say, for me. So I have that, and then I also talk to people who have more recently taken it. So I have some indication, but I've got no sort of super secret knowledge of what's going on in these tests. So I'm going to focus primarily on that. So necessarily there won't be much forward-looking stuff. Might be a little bit sneaky in every now and then. But if I kind of have to say this to get King out of jail. If I do let one slip out, then please don't base your purchasing decisions on any of that. Only go for the commercially available software. I'm sure you've seen that before. And of course, copyright material. So this is primarily looking at, this session, we're looking at folks who are interested in attempting the Platform Developer 1 credentials. So we're going to go through, talk a little bit about the exam, and then we're going to try and cover the main topics. We're not going to achieve 100% coverage, and that will be very difficult to do in 5 hours. We're going to give it our best shot and see how we go. These are the modules, and we try to do this more or less based upon the categories in the exam. So a bit about Salesforce fundamentals, things like multi-tenancy and stuff like that, data modeling and management. The main, meat of the cert is about what we call process automation and logic. So we've split that up into two sort of manageable chunks, hopefully. Talk a little bit about the user interface, and this will include things like Visualforce. Yes, Visualforce is still part of the test, but also Lightning components. Short section on testing and debugging and deployment, and then a bit of wrap up at the end. So that's the sort of the agenda for today. Not too sure about timing. Like I said, we don't run these things very often. We usually sort of memorize timings and stuff like that, but just going to wing it today, and hopefully we will be done by 2 p.m. UK time. So a little under 5 hours from now, with a couple of breaks, I hope. So without further ado, let's talk about the cert itself. Typically, it does help if you're going to do this certification, if you've had some programmatic experience in your career. Apex itself is very like Java in terms of its syntax. So if you've done Java development before, you're in a good starting point. If you've done C# development before, really almost any sort of object-oriented type language will help you out there. It's not super necessary for the cert because really you're not going to do anything complicated with code. You're not going to be, writing code in the certification, but you will be answering potentially questions about things like code snippets. And you also need to know the platform to some extent. It's very difficult if you've got little knowledge of the Salesforce platform. And by that I mean things like, what an object is, what fields are, the clarity of tool set that we use for automation. So things like workflow rules and processes and approval process and validation rules, all of those kind of things. So you should be fairly comfortable with that. Certainly when I deliver the training for this, which is actually a 5-day class, the people who come on that with minimal experience of the platform tend to have the toughest time because they use words and terminology which is kind of alien to them. It's not difficult, it's just hard to sort of get your head around those terms if you're not that familiar, with the platform. Well, these are the categories, I think, that they've split the exam up to. So we sort of modelled this session on those categories, and they contribute different weights to the overall content of the exam. There will be 60 questions. They will all be multiple choice. There's usually 1, 2, sometimes even 3 answers that you have to select as you go through those questions. And before you move on to the next one, you have to choose the right number of responses. So if they say choose 1, you've got to have selected at least 1 option for what they give you before you move on to the next question in the test. Now, you've got to get, it's usually about 2/3, 65%, of those right to achieve a pass mark. And I think it's about 110 minutes now, so you've got a little over 90 seconds per question, which doesn't sound a lot, but honestly, nobody really runs out of time on these tests. When you go through it, there are going to be some questions in there that straight away. It'll take you 10, read the question, oh, I know that, click, done, move on. And hopefully there'll be more than one of those. There's going to be some where you think, but you're not 100% sure, and there's going to be some where you actually have no idea what the hell's going on. Whatever it is, you've got to make a choice. And the good news is for those ones where you're not sure, you can mark those as, let's come back and review those later. So what I usually do, and I have to take all these tests as part of my job, is, I'll go through it all, I'll mark the ones where I'm not sure of the answer, and then when I get to the end, I can look back and I'll focus on the ones where I've indicated that I'm not sure. If you look back and you think, oh, there's actually only 20 where I wasn't sure, you're in a really good place because you've probably passed. Because if you're sure about 40 of them and you're not sure about 20 of them, there's a really good chance you've got that, 2/3 deal going on. If on the other hand, there's only 20 you were sure about and there's 40 you've marked, then you've got to you've got a bit of work to do. People approach this in different ways, though. That's kind of what works for me. I mean, you all have your own ways, I guess, of managing this. Remember, if you take this online, as most of us have to do at the moment, you don't have a bit of paper or anything to actually make any notes on. So you actually do have to do it bare-brained. If you go to a testing centre, when we were allowed to do that again, they will give you a bit of paper and pencil to sort of make notes. But when you do it, I think online, I don't think you get that luxury. Not a lot else to say about that. If you do manage to pass, that's great. Well done. If you don't be disappointed, because these things are not that trivial to do. People do fail all the time, and that's part of learning this whole process. Retakes are going to be available to you, and like I say, you've got that voucher code, so it will cover the full cost of the retake up to the 3 exams limit. Right then, and finally, I suppose if you do pass, or when you do pass, woohoo, for start, but also remember you have to maintain that certification. I think we've changed the rules recently, so there's kind of like a maintenance exam which is done via Trailhead, so it's not a scary thing. I think we're doing it once a year now rather than 3 times a year. I think that's just changed. So let's get into the guts of this, guys. Hope you can all still hear me. Looks like you can. There's a good few of you attending from around the world. So the first bit was about the first category, Salesforce fundamentals. This multi-tenancy environment, some sort of high-level questions likely about the architecture of applications, model view controller, maybe a bit about Lightning Component Framework, maybe a bit about the interaction between declarative and programmatic tools. Scenario questions are always very popular for the certification guys here. So given a scenario, how would you do it? This kind of thing, and they'll give you a number of options. Not a massive amount of the test here, though, 7% of the cert. So the first thing is to understand this whole multi-tenancy stuff. You don't have to understand the gruesome details. They are available to you. There's actually a white paper and also quite a good webinar about that. But you need to understand that when you're talking to Salesforce, when you open your browser and you log in, you're going to see in the URL the pod, something like EU0 or UM1 or AP0 or NA 74. Basically it'll be a unique identifier, which is called the pod, the point of deployment. Now, what physically that is a cluster of Java application servers in a data center somewhere. So NA would be North America, EU would be Europe, I think because of Brexit, don't get me started. We have UM now for the UK and AP for Asia Pacific. So it sort of identifies the geography of where the data center is, and there's usually multiple data centers in that geography. So you're talking to this cluster of application servers, and underneath that, the main persistence mechanism, not the only one, but the main one right now, is Oracle, big fat Oracle database underneath that. Now, there's obviously a lot of stuff going on here. In that Oracle database, for example, when you're talking to an account, you're working, let's say, with an account object or maybe some custom object, and you're designing that, you're adding fields maybe, or you're writing records or reading records that belong to that object. You're not really working with a table in that Oracle system. We have this abstraction layer that sits between between the Java application server essentially and the Oracle database. So you're really talking to an abstract table, like an account table or some sort of custom object table. It's not really a table in that Oracle database. What's actually in Oracle is a kind of a very weird structure, and I think there'll be some discussion of that in that white paper if you care. They won't go down to this level, by the way. I don't think for the certification, you're not going to be asked questions about the structure of that Oracle database or anything like this. But bear this in mind a little bit, because it helps you kind of understand why Salesforce works the way it does sometimes. You're working through this abstraction layer that's sitting on top of some other persistence mechanism. In Oracle, you can almost think of it like that. It actually has two main tables. One's called metadata, and one's called data. So let's say when you're adding a field to a custom object, or a standard object actually, or you've written a bit of code and you've stored an Apex class, that's metadata. You're adding entries to that metadata table, which we all share. So that our stuff, my stuff, is kept separate by your stuff by a unique org identifier. When you're adding records to a table, like you're adding an account record or some sort of custom object record, then that goes into a data table in there, again, which we all share. And a system keeps everybody's metadata and data separate, based upon their unique org identifier. So a lot of that is discussed in that white paper, and there's also an associated webinar. Like I say, you will not be asked those gruesome details, but it's good to bear in mind. It's always helped me kind of understand why Salesforce works the way it does. Also remember that there's thousands of us sharing that pod, that point of deployment. It's not just you, it's thousands of other customers, and these are usually production systems. So that's what we mean by multi-tenancy. We share that environment. And Salesforce goes to all sorts of tricks to sort of make sure that what I do isn't going to interfere with what you do. So if you've been working with Salesforce for any length of time, you'll be used to limits. We limit everything you do, particularly when we start talking about code. So we will touch upon that as we go through. An understanding of these things we call governor limits, is important, and they will almost certainly test that at some point in the certification exam. Also, things like the architecture, not huge here, and they're not going to ask you difficult internal architecture questions. Some sort of familiarity with what we might call MVC, Model View Controller. It's not a bad thing, but it's not a big deal. By model, we mean the database, the Salesforce database, all the objects, custom objects, standard objects that you know and love. By view, we mean the UI. So if this was the classic, this would be things like the classic pages, page layout in Lightning Experience. It's our Lightning Experience, Lightning Component Framework. It's our Lightning Experience application, or communities, or the mobile. So basically, it's the UI. And then what we would call the controller is really just a lump of software that sits between the two. If you think about it, you're looking at a page. In Lightning Experience, you're seeing data that's come out of the database. The controller is just a lump of software that enables that. It gets the data out of the database and presents it to you in the view or the page, and also has the capability to go back the other way. You make changes, you press the save button. We want to take that data from the view, from the page, and stuff it back into the model, into the database. And that's the job of the controller. It does other stuff as well, but fundamentally, that's the deal. So, there's a few questions here. They're going to be largely rhetorical as we go through the week here. Is a custom object past the model, the view of the controller? It would be the model. It's the database. All objects are really part of the model. If you were referring to page layout, or let's say build a record page, is that part of the model, the view of the controller? That's what's in the view. It's in the UI aspect. So again, don't go too mad here. We're not being religious about this kind of thing. Just have a sense of what we mean by that model view controller deal. Now, another favorite question of those pesky examiners is you will often see questions like, well, we want you to do this. How would you do it? Here are the options. And they'll do things like, would you configure it perhaps using the out-of-the-box declarative tools. And by declarative tools, the sort of stuff that you can configure in setup. So if you want automation, processes, flows, workflow rules, all those kind of things. So that's what we mean by declarative. Point and click. Click's not code. Those are the examples. Then there are other options. Well, okay, should you buy it in? Should you go to AppExchange and see if you can download a package there, or maybe a component that's either going to solve your problem completely or at least help you to solve that problem. which is great. There are things to bear in mind if you do that. Somebody else has got to help you support that because you might be using third-party, components in there. What about support? What about maintenance? But the good news is it's already built, so it should be quick. And if none of that works for you, then the programmatic solution. Inevitably, you want to do something that's either very difficult to do declaratively or impossible. There's no good options on App Exchange that are going to help you out or solve your problem, so you kind of have to go build it, and that's fine. But they like to sort of ask you these questions, so don't neglect the middle one here. I don't know if you can see my mouse wiggling around on the screen. Don't neglect the sort of the App Exchange bit, the build bit. We want to go code stuff because we can, but they do like to sort of pose questions in these tests to remind you that App Exchange is there. So look at it carefully and see what they're saying. If they're saying they want some sort of weird package to do X, then often that would be, the answer is going to be something that would include, go see if you can get it on App Exchange. Can you buy it in rather than just jump into building it? Because there's always that temptation to jump straight to code. Now, there isn't going to be an expectation for this cert that you do know about the automation tools. We're not going to cover it today. We just don't have time in the 5 hours that we have, together here. So you will need to know, or you should know, a reasonable knowledge about what a process can do for you, something you create with Process Builder, what you can do with a flow, both a visual flow and the non-visual sort of auto-launched flows. I think we can do. What can you do with a workflow? Or what are the actions that are available to you? What is it like to build up an approval process? So there is this assumption that you know what the capabilities of the declarative tool set are. Because one of the things they validate is if you want to build a solution in a Salesforce, we don't want you to reinvent the wheel. If you can do it declaratively, without too much pain, and it works well in bulk and all that kind of good stuff, then you probably should. Don't always jump to code. So there's going to be that implicit assumption that we know the declarative tool set. We ain't going to talk about it today, but you do need to know a little bit about it. So, for example, I've got 4. This is not a complete set. We're not talking about things like duplicate rules or validation rules here. So these guys here, for example, if I said to you, do they support time-based actions? And it would be, well, yes, we can with a process. Absolutely, we can with a process. We can do it with a flow, both a visual flow and the non-visual aspect of that. Absolutely with workflow rules, immediate actions or time-based actions, but not with approval processes. User interaction. Do we have a screen to play with? Well, no, not with a process. With a flow, I put a little asterisk there because if this was an auto-launched flow, no. But if it's a visual flow, the clue is in the name, of course, yes, there's a screen for a user to interact with that flow. Workflows, no, not really. Approval process, kind of, because you're sort of going through the UI to sort of approve or reject, steps in an approval process. So I made that a yes. Now, can any of these call Apex code? Well, yes, you can from a process. Yes, you can from a flow, both forms. If you do that, you have to configure the Apex code very carefully. You have to mark, methods as invocable. And actually, we're not going to cover that in the next couple of hours, but I do know, because I talked to one of my colleagues who talked to this test a couple of months ago, and by the way, this test was refreshed at the beginning of this year, that there was a question about invocable Apex in there. So maybe just read up about it a little bit, see what you have to do to write, to mark an Apex method as available to a process or a flow. It's just an annotation. So just go read up on it real quick, because there may, he told me there was some sort of question about invocable Apex. So make sure, and that really means calling it from a process or a flow. So take a look at that. Just go read that up, that little bit in the documentation. Didn't have time to sort of put anything about it in here this week. Workflows, no, can't play in that game, neither can approval processes. And finally, another good one for the examiners is about deleting stuff. Can you delete a record? Well, the process builder, no, that's not an option, but it sure as hell is in the flow. So all the automation tools, all of the declarative automation tools, the only thing that can actually delete stuff is a flow, either a visual flow or an auto launch flow. So that's all. Again, always a nice thing for the examiners to torture you with, because there's only two ways of deleting stuff: automating that, either going through a flow or, of course, using code, because code can do anything. So I hope that sort of wakes you up a little bit about that. Moving on, we're in module 3 already. It's only 9:30. A little bit about data modeling here. And this is really, again, the sort of thing that you might see are, it'll give you requirements. You want to build relationships between objects. You have to make choices about those relationships. And that means you need to know the capabilities of those relationships, what they can and cannot do, and their impact on things like security. The options available for moving data in and out of Salesforce. Again, not super detailed, but broad brush. And also particularly things like, formulas and roll-up summary fields. They love to ask you about stuff like that. So we're just going to kind of touch on some of this in this module here. This is, let's say, 13% of the exam, so it's not a massive amount, but there's a good chance if there are questions in here about this sort of stuff, this should be meat and drink to you. You should know this stuff pretty well, particularly if you've got any previous certifications, so if you're like admin certified or something like that, or app builder. This should be easy peasy lemon squeezy if they get you questions like this. So let's have a look. First of all, what do we mean by an object on the platform? Again, it's helpful, and I certainly do this, think of an object in terms of a table, which at an abstract level, it absolutely is. So tables have columns, objects have fields. Tables have rows, objects have records. So they're very analogous, like that. Remember that for every object, you have a set of standard fields, things like ID and owner, and those sort of auditing fields like last modified by and created by. Everything's got those. I actually like to use the term system fields for that, but I think the documentation still calls them standard fields. What's confusing is we also have standard fields on the standard objects. So if you look at an account, for example, you're going to have a shed load of fields out of the box in there, in addition to things like ID and owner and last modified by. There's loads and loads of other stuff as a standard on that standard object. Custom fields, you can add those to standard objects, you can add those to custom objects. Remember, those pesky standard fields on things like account and content, you can't get rid of them, nor can you get rid of account or contact objects on those CRM objects. The best you can do is ignore those objects or those fields, or you can reuse them as part of your solution. Relating objects together, we'll talk about that in a little minute in a bit more detail. Validation rules, custom validation rules. Remember, you can apply these to standard or custom objects. I think to the limit of 100 or so per object. They can be quite sophisticated, but they're based around a formula. They return true or false depending on whether something is invalid or valid. So an understanding of those capabilities. Things like record types, how these work with different page layouts. Also, what does a record type control? Well, it can allow you to have a different page layout, both in classic, and in Lightning Experience. It also controls, pick lists to some extent. So you can be very selective about what options you show in a pick list. So make sure you're comfortable with, the way record types work and how they're, how they're attached to things like profiles and or permission sets. And of course, all the automation tools like workflows, processes, flows, and approval processes. Be pretty comfortable with those as much as you possibly can. And then there's security. Now I don't think we have time to go through the security model here today. At least I don't think we do. If it looks like we're going to finish early, if I've exhausted myself and you, we have 15 minutes to go, I might try and do a summary of the security model for you guys. I actually did a Trailhead live session on that recently for the app builder certification, but it applies everywhere. I have like a couple of slides I usually like to go through that it'll summarize the security model in a way that actually made sense to me. So this is things like authentication, who are you, and how we do that, at least not in massive detail, but enough so that you for the purposes of and then the authorization part, where the system knows who you are. So what objects, what fields, what records, what system permissions will we give you access to, all of that kind of stuff. So particularly things like object security, field level security, record sharing, you should know as much as you possibly can around that. And I did a Trailhead live session on that a couple of weeks ago. So go look that up if you're unsure. If I get time, I might repeat it here, but I'm not sure I'll have time for that. So relationships, what relationships can we add in Salesforce? So I'm hoping you know, so this is very much a review. There's just two, right? Master detail or lookup. Important aspects of master detail. The most important one is the one we're referencing on the slide here, the way sharing works. Sharing for the detail record is inherited from the master. Simon has access to the master record. Whatever level of access that has, I'm going to have the same access to the detail record. So they are not independently securable. Now, there's other stuff here, things like we have a cascade delete thing going on. So if you nuke the parent, it's going to delete the child records. It's a required field. You can add orphans here. So the child must have a parent, and you can optionally allow reparenting. Things like lookup filters work. Don't be distracted by the word lookup. This applies to master detail records. What's another favorite one? The detail side of a master detail relationship must be a custom object. It cannot be a standard one. The master end, standard or custom. The detail end, got to be custom. And not all standards objects can be masters. For example, user can't be. So there are some tricks kind of around that. But the most important thing is about security. If they can show you a question where they might give you a big old load of text about to relate these two objects together, and they'll give you a bunch of options, should I choose master detail or master lookup, basically. If they say they want different security at the end of those two relationships, you cannot use master detail. So this should be the first thing that kind of sticks in your head here. So if it's not master detail, it's going to be lookup. You can think, I'm just going to go back a slide here. You can think of master detail as tightly coupling those two objects together. A lookup can potentially be a much looser coupling of these two. So you have tunes you can play. You can make these relationship optional. So you can have, you can have orphans then, or you can make it required, kind of like a master detail. You've got options about, if I delete the parent, what shall I do? Well, if it's optional, you can just clear the value of that field. Just remove the foreign key, if you like. And actually talking about that, remember all this relationship stuff that we talk about, it is really boils down to primary key, foreign key relationships. You're used to working, in previous careers with relational databases, where you talk about primary keys and foreign keys. It's really the same thing. Primary key is just Salesforce ID. Foreign key, we don't call it that in Salesforce, we just call it the relationship field. Either lookup or master detail, it's still just the foreign key. So, if this is an optional field, we can, you delete the parent, we can just clear the value of that relationship field, we can do a delete prevent, don't allow deletion, or you can actually have cascade delete in here as well. That last option needs to be enabled by support. It's not there out of the box. There's a good reason for that. If I go back to master detail, Simon comes along here, I delete this account record, it's going to delete the customer story records because of this cascade delete, but then that's fine because I have access to both. Okay, so there's no sort of serious security implication from that as long as I have delete access to the objects. But here, maybe if you want to turn on cascade delete for a lookup relationship, you have to be careful. Simon might have access to the contact record here, but I might not have access to the customer story record. Not necessarily the case because you're allowed to have different security. But if we have a cascade delete kind of deal going on here, if I delete the contact record, it's going to go and delete customer story, even though I do not have access to that record. So when you get that turned on by support, they want to make sure you understand that potential issue and you're comfortable with it. And of course, you can add a lookup filter to this as well. I hope this is making sense to you guys. The other thing is schema builder. They do occasionally like to throw in a question about schema builder, those pesky examiners. So make sure you're comfortable with it. A lot of people ignore it. It's not the most popular tool we've had. It's actually okay. And it's not bad for sort of talking about the schema maybe to analysts and stuff like that. So just make sure, and I'm just going to whip out an org here and just dive in real quick. So here's an org that I can play with. Let me just search for schema builder here. Just make sure you understand what it can and cannot do. So you'll probably, if I just clear all these guys out and I just put account and maybe contact back in here, and I just do, oh, there we go, it's actually laid it out fine. You're probably used to, as I am, if you're working with your org, to using Object Manager to manipulate, to design these objects, add new custom fields, add new objects, add relationships between them. Most of us will do this through Object Manager. You can do some of it through Schema Builder. For example, I can go here and I can add a new object. I can drop it in like that. You get a little wizard. I'm not going to go add the object in here. Or I can, maybe an existing object here. If I wanted a new, number field on contact, I can just drag that from the elements and drop it in here, and it'll add the field. Works pretty well, but it has a couple of drawbacks. Just make sure you're aware of these. One is that when you add a field, if you do it through the setup pages, it's going to allow you to add, to set field level security on that field as part of the wizard screens that you go through, and also ask you about adding it to the page layout. If you do it through this tool, it does neither of those things. You have to go and do that. You're going to do that separately. So that can be a bit of a pain. And the other thing is when you add an object, again, not all of the options are going to be available to you in this tool that you normally see on the setup pages. So, you don't have to be super, adept with this thing, but just be aware of some of the things it can and more particularly cannot do compared to what you're used to using on the setup pages. Let me just get rid of that and get rid of my org here. So I'm not going to go through these questions with you guys here. Data management. This is really about what you can and cannot do with data import wizard and tools like data loader. Always been a bit of a favorite of the examiners. Let me just have a quick sip of tea here. Oh, no tea, I have to use water. So data import wizard is built into the setup UI. So it works okay. It's limited to a maximum of 50,000 records. So if you want to import fewer than 50,000, the data import wizard, and import only, by the way, the clue is in the name is an option. But of course, data loader can do that as well. Data loader is a standalone tool that's available from Salesforce. And there's loads and loads of third-party tools out there that do a similar thing. They actually connect through these standard APIs, same as data loader does, really. So often if there is a question about I want to import 200 records and giving you some options, data import wizard is a valid option for that. One they do like to ask occasionally is doing things like preventing duplicates and choosing whether or not to trigger things like workflows or processes. A process is the same thing here. And you can disable that capability with Data Import Wizard, and you cannot do that through tools like Data Loader.
Okay.
However, you want to mess with more than 50,000 records, then of course tools like Data Loader is great. Data Import Wizard is very restricted in the number of standard objects it can work with, only a small number, not, for example, product opportunities or custom objects are fair game. So you can't do that. You would have to use Data Loader. Any sort of scheduling, command line, of course, Data Import Wizard, no. Tools like Data Loader, because you can run them command line. You can, if you're on Windows, for example, you can use Windows Task Scheduler. You know, you can schedule stuff like that. One very annoying thing about Data Import Wizard, it does not preserve mappings. So if you're uploading a comma delimited file and you're mapping the headers in that file to the API names of fields from objects, you know, often if you're lucky and if you carefully name those things, mapping is easy. But if you have to do a lot of work to sort of get that mapping, then Data Import doesn't save that. So you have to do the same thing next time, whereas Data Loader, tools like that, pretty good at that sort of thing. And of course, Data Import Wizard, the clue is in the name. It's imports only. So if you want to do exports or you want to do deletes, again, tools like Data Loader. Don't know how much they have out there about those things now, but you know, this is, you know, if they do, it shouldn't be a, you know, a difficult question.
No.
Just make sure you're aware of the capabilities of those tools. What else have we got in here? So that's a bit about that. Oh, we're going through this now here. Process automation. So this is the chunkiest part of this. So this is the bit that we've split into two. This is 38% of the test. So this again, you know, this will evaluate your knowledge of, you know, what is there out of the box with, you know, the process automation features. What can you do without having to jump into code? Also, then it'll look at the language itself at Apex, and you know, some basics about the language, so variables and modify constants and properties and methods and interfaces. We're going to talk about some of this stuff. You know, often, you know, scenario questions about how you use Apex, and particularly how it interacts with the other process automation features. There might be some stuff about some of the inheritance mechanisms in Apex of things like interfaces and virtual classes. Got a slide on that. Don't think there'll be a lot. Hopefully I'll be able to, you know, just cover the sort of thing they might try and ask you about. A knowledge, of course, of search language, SOSL, query language, SOCL, DML statements, you know, pros and cons of using those. So, you know, a good familiarity with those guys is definitely something that they're going to look at. Exception handling. How do we deal with errors? How do we manage security with Apex? And that's really an important one to think about. Security is always a big deal. There's always questions about security in some shape or form in all of the certifications. So a knowledge of, you know, what is the security model and how, particularly how Apex interacts with that is going to be really important. I think it's kind of almost said this already about how it interacts with the clarity of tools. And something they've added recently, I think, this appeared in the refresh of the test that they did at the beginning of the year. Platform events. You know, these are one of the streaming APIs. I don't think they're going to ask you about all the streaming APIs, but it does explicitly mention platform events in the exam guide. And my colleague who took this a couple of months ago, who's a new instructor, he did mention they asked him about platform events. So I popped a couple of slides in here about that. Again, it won't be massively complicated, but you know, a good high-level knowledge of platform events. There's a question of it should be pretty easy. That might be an easy win, as long as you know a little bit about platform events. So let's talk through some of this. We're going to start not with code, but with formulas. Okay. Now, hopefully, you guys are all familiar with the likes of a formula. got a couple of things to say about it, which are not necessarily something you may know, and I'm not sure they'd examine you on this, but they might do, those pesky examiners. So let's take an example here, and this is actually a code snippet from one of our training orgs. Got a couple of custom objects. Let's say we have a training course, which has things like, what's the title of this particular training course, like the one we're on today almost. It has a start date in there, a duration rather, how long the course will last. And then you'll have, instances of those courses, multiple deliveries of that particular course. So, a structure like this is, not an unreasonable thing to see here. Now, in a particular data model, you might have on the course delivery, it's going to tell you when it's going to start. Seems reasonable. This course is starting today, Tuesday, 5th of May. But when does it end? Okay. If a user wants to know when it ends, they could go and look at the parent course record. This is a master detail relationship by the look of things. We conventionally show those in red. And they'll see the duration of the course and they can work out the end date. But wouldn't it be nice, friendly, to tell the users when the end date is? So a formula on this course delivery object would be a reasonable thing to do. And I think I've got that in my org here. So if I just show you real quick in this example, if I go into Schema Builder, let's just use this just for giggles, just to give you guys a feel. And let me just clear these things out. Let's look at custom objects. And I'll select course and course delivery. So these two guys. Whoa, I didn't want to select all, did I? Let's do that again. Course and course delivery, there they are. Let's try some layout. Okay, so we have the master end on the left and we have the detail end on the right. And you can see this kind of stuff going on. You can see on the course we have a field called duration. And you can see start dates lurking down here. So these are persisted fields. And actually the formula already exists here. You can see there's something called end date. So let me just go and have a quick look at that. I'm going to use object. And I'm going to go find course delivery. Fields and relationships. There is end date. You can see it's a formula. It returns a date. If I edit this thing. Then down here, if I zoom a little bit, I hope you guys can see this. You can see the formula there. So start date. So this is a field on course delivery, and then you've got this kind of deal. This is called relationship traversal here. So if I just zap that, and I add that in again. Now remember, if you know what you're doing with these formulas, you can type it in, but you've got these nice little buttons. So why the hell not use them? So insert field, this is showing me what's on course delivery, and I can see start date here. There it is. And then I want to add the duration. So plus, or you can insert the operator from here. And then this is the kind of interesting bit, the bit I want to just focus on just briefly. I want to get to the parent here called course. Now I have two mentions of course in here. I have that one, and I have the one with a little greater than sign next to it. So this guy, the top one, if I choose that, that's going to give me the relationship field. It's actually going to give me the ID of the parent record there, which is great, but I don't care about that. If I choose this one, it's the thing that does the relationship traversal. It's the thing that shows me the fields on the parent object, and I can set duration. And it will insert it, and it will create this syntax for me. Okay, so underscore R, a reference to the parent course record dot duration, and then -1 will give us the correct calculation. The important thing is, I didn't have to understand how that syntax worked because these little buttons did it for me. When we come to work with SOCL, the query language, there are no little buttons to help you. Usually, so an understanding of that in the top of your head is important, and they will test you on that. So knowing how this relationship works, how this syntax is put together. So I'm going to talk more about that when we come to talk about SOCL in a minute. But what I want to ask you here is that value. If I complete that, I'm just going to cancel this because this formula already exists. And if I go find a course delivery record, I should have some in here, I hope. Let's pick one. I don't think it really matters which one I pick. So you can see I have start date here and I have end date there. So start date is a persisted field. It's a regular date field. Its value is stored. End date is a formula. So when are formulas calculated? This is one question. They are calculated when you view the record. When the record is referenced, that's when the calculation takes place. The value, that value there, is never stored anywhere. It's only calculated as it's needed on the fly, and when I move off this record, it's kind of thrown away. Okay? So that value is not stored anywhere. So that does mean you have to be slightly careful about the use of formula fields. Later on, when we talk about SOCL, we could say, select me a bunch of course delivery records where the end date is, the 15th of September, for example. Which is fine, that's a valid query, but, and if there's just a few records in that course delivery table, who cares? But if there's 100,000 course delivery records in there, what you're asking the server to do is to go through all 100,000 records to calculate end date, just maybe to select one or two of them that match that, that where clause. So be careful about the use of formulas in things like where clauses or actually in reporting in filters. Because the server doesn't store those values, it has to calculate them on the fly, and it can be a real downer in terms of performance. The other thing to talk about, I just go back to the slide here, is these are fields that belong to S objects. Start date is one, duration is another. Okay, so fields carry field level security. So we can set field level security against profiles and permission sets. So what if Simon comes along? I have access to this formula field. Okay, that's great. My profile or permission set says, yes, Simon has read access to this formula field, which is what I would need to see it. I might have read access to the field here, start date, but maybe I don't have access to duration. Okay, I don't have access to that duration field. And what's going to happen to this calculation? I, Simon, have access to start date, but I don't have access to duration. What's going to happen? And the answer to this, and again, it's kind of a little rhetorical here, is it will still work. You need to understand that Salesforce has this concept of something called user mode or system mode. And it really means user mode, and sometimes you'll see it called user context or system context. User mode means obey all the security rules. Okay? Only give access to the things that the security model says you have access to. System mode means ignore all the security rules. And formula calculations happen in system mode. Okay? So it doesn't matter if Simon has access to any of this stuff. As long as I have access to the formula field itself, read access, I'm going to see the result of that calculation. So this concept of user mode and system mode comes up a lot in Salesforce. Processes, for example, run in system mode. Auto-launched flows run in system mode. Visual flows run in user mode, for example. So be sensitive, be aware of the way we apply security. Most Apex code is going to run in system mode. And there are things we can do in Apex to respect the security model, but basically it runs in system mode. If you don't tell it to, it will ignore the security model. So be familiar with that, understand how we work with security with all these automation tools. A final point about this, if you are going to do this relationship traversal stuff, hopping up from child to parent, you can go up 10 levels with a formula. You cannot go the other way. You could not write a formula on course, would reference stuff on course delivery, but you could only go from child to parent. Okay, so I hope that makes sense for you guys. Roll-up summary fields. So remember, these things can only apply at the master end of a master detail relationship. And they're very simple sort of aggregation tools. They can only do 4 things. They can count number of child detail records, and they can do sort of sum, min, or max aggregation on numeric or date fields, that you select here on the child, on the detail. Okay, that's it. They cannot do anything else. The favorite certification question of all time is to try and get you to say that roll-up summary fields can do an average, which they cannot do. Okay, you want to do things like averages, you have to throw in a formula in there as well. Out of the box, roll-up summary fields is count, sum, min, max on numeric and date data. That's it. So don't be kind of caught out by that classic average question if it's still in there. They've asked it so many times, they may have got bored with it, but it might still be lurking in there. And remember, of course, you can filter the results of the detail. So you don't have to do this aggregation on all detail records. You can apply a filter to those. Again, this is a system mode deal. When are roll-up summary fields calculated? And now the actual value of a roll-up summary field is actually stored, it is persistent. So you don't have any worries about shoving these into things like where. But when is the value calculated? It's calculated when something happens not to the master end, but to the detail end. If you're counting, for example, the number of detail records, then that roll-up summary field will be updated. It will be recalculated and saved when, let's say, you maybe add a new detail record or you delete an existing one. Okay, you do something at the detail end, it triggers the recalculation and save on the master end. And that's important to know. That has quite a lot of impact on things like the order of execution. Okay, quick drink. How are you guys doing out there? You all still hanging in there? So, basics of the language. Cloud-based, object-oriented, good. It's been around for a while. I want to say 2007-ish, I think Apex hit the scene. Currently, and this was a statistic that came from, I think, the last Trailhead DX conference, I think there's something like 850 million lines of Apex code in production right now, over something like 200,000 production systems. So there's a lot of code out there. The code itself, it's kind of designed as far as possible to make some things very, very easy. So if you're working with data from the Salesforce database, getting it out to the Salesforce database or putting it back in, super easy, It's very Java-like in its syntax, but you don't have to mess around with JDBC here. It's very, very easy to work with data, to get stuff out of the database, put stuff into the database. Works in conjunction with all the declarative features. We'll talk about that when we come to the order of execution. It's completely metadata aware. So the code knows about all the objects you have in your org. It knows about all their fields. It knows about all their data types. All of that stuff is automatically accessible to Apex, which is awesome. And very different, though, from other languages, it works in this multi-tenant environment, which means we limit what you do. You can't write infinite loops in Apex. You can try, but the system will stop you after a certain amount of time. So, that's running mad. I'm going to blow you away. So these things we call governor limits will seriously limit what you do with Apex code for a good reason, because you're in a multi-tenant environment. We are sharing all this kind of good stuff. We want to make sure that you do not consume the resources on that pod that will affect somebody else's work. Now, when code, and here's some examples of Apex code, remember, references a field, it kind of locks it down. I hope you're aware you can change things like field labels as you see fit with referencing a field, because these are cosmetic. They can be translated, they can have spaces, they can have national characters. But field names are used to generate the API name of a field. So this is the thing where the system applies this __C thing on the end. They can be changed unless you're using them in code, in which case they become locked. So if you do reference that field, for example, in code, you cannot delete it. It'll say, you try it, say, no, can't do that, you're referencing the code. You want to delete it, you have to remove all the references to it, and then you can delete the thing. Or also, you cannot change the data type. We're treating this thing as text here. You're not going to be able to change the data type of the thing either. Okay, you want to do that, you're going to have to remove the references from code to to be able to achieve that if that's what if that's what you guys need. So remember, all of that is tracked. There is this dependency between, as soon as you start using objects or fields, in Apex code, there is a huge dependency between the metadata and that. The reason is, if we allowed you to sort of mess around with that, it would invalidate that Apex code, and that's not allowed. Apex code has to always be syntactically correct. So if that location field disappeared, then that would invalidate that code, and that's really not allowed. What are the primitives for the language? These are they. Most of these are the same as primitives that you'll see in most other languages, to be honest. Things like text, strings, integers, time, date time, booleans, blob, binary large object, for storing things like files. The only one that's perhaps unique is ID. So this refers to Salesforce ID. Salesforce ID is a 15-character case-sensitive string that's actually stored in the database, although it does appear sometimes in its 18-character form. These things, when we initialize those, they can all be initialized to null. You don't have to create instances of these things. They have classes associated with them, and they're very, very well documented and fairly easy to use, actually. So I'm really not going to bang on too much about the primitives that you'll work with. Most of these are fairly intuitive in here. These things, though, you do need to be comfortable with. When you're writing Apex code, most of the time you will be working not with a single record, but with collections of records. Bulkification, we call it. And there are 3 collection data types you do need to be comfortable with. These are list, set, and map. So I just want to talk briefly about these here, just to remind you guys. So if we take a list first, lists are ordered, indexed collections of elements. So for example, here, if I look at this code on line 1A, we are creating a list of accounts. Now remember, Apex is what they call a strongly typed language. You declare a variable, we call it accounts here, you must give a data type. And the data type is a list of account records. And that means you promise that you will put a list of account records in there. Nothing else is going to make the syntax checker happy. So we initialize it on the right-hand side. We're using the constructor, the new keyword here, for the list class. This will construct a new list, and it will be an empty list because there's nothing in the parentheses here of account records. So that says that variable accounts is going to be initialized to an empty list of account records. And then we add a couple of elements to the list. So the add method, and we are creating inside the parentheses here on the fly a new account record called account 1, and then we're doing the same thing with account 2. So again, all this is in memory. I keep saying record here, but none of this is touching the database yet, of course. And then when you do that, how do we sort of access the elements of that ordered indexed collection? We just use the index starting at 0. And a couple of ways of doing that. You could use the get method with the index in there. That's going to retrieve account 1. Or you can just use this array syntax, which will retrieve the second element because we start counting at 0, and that's going to be account 2. So again, if you're not sure about these things, it's usually good to play a little bit. So if you don't understand or you're not clear on what these things mean, do what I do and just play. Just go into a tool like Developer Console, and I'm just going to go in my org here. I'm going to open up Developer Console. You should be familiar with this guy. You get to it in the setup through the little gear icon. One thing I would counsel you to do, I don't know if you know this already, so apologies. If you just click on the link here, it tends to open Developer Console as this floating window, which is fine, but occasionally for me, over the years, it's had the odd psychotic moment where it sort of shrinks itself down to a tiny little box, which is embarrassing. So what I usually do now is I make sure I open link in new tab. and I just open it up as a tab in my browser, and it seems safer that way to do that. We'll just close some of these log files down. So to play, remember you have this tool called Execute Anonymous, Control E. So I'm just going to drop in the code that was on that slide here. So Execute Anonymous, kind of a weird name because you're not anonymous. It knows exactly who you are. And the actual code here runs in user mode. It will obey all the security rules that you actually have in this window. I am, though, an administrator of this org, so I'm pretty much god of it, so I don't have to worry too much about security. So if I run that, I've got two system.debug. Let's throw things at the debug logs. I'm going to get the first element of this collection and then the second element of this collection. So I do execute this thing and go and open up the debug log. It's going to show me that. So first account is account 1, second account is account 2, as you might expect from that little bit of code. Okay? If I look at the next one, these are sets. So a set is an unordered collection of elements, but so you can't really refer to these things using the index. But the big difference is it can't contain duplicates. A list, we don't care. But sets, we do care. So for example, you've got a set of strings this time called names. We initialize it to an empty set of strings. We're adding 3 elements to the set. The string Acme, the string Salesforce, and the string Salesforce again. And then we're asking the question, does the set contain the string pardot, so the contains method here? And hopefully not. That should return false. What is the size of the set? The size method, how many elements in the collection? Well, what do you think from that example? Let's run the code. So if I take that little bit of code here, I've got this off to one side, pop that into my Execute Anonymous window here. Let's just get rid of all that. Paste this in. So I think this is the code that was on the screen. There we go. Get rid of that log file and run it again. And let's look at the debug content. Does the string contain the set? Does the set contain pardot? No, false. Size of the set 2 elements, because essentially that one will have overwritten that one when we add it to the set. So it's useful for doing things like screening out duplicates. And finally, maps. Perhaps slightly most complicated, but one that you must be familiar with. We use maps extensively in Salesforce. This example is declaring a map, and we use key value pairs in here, where the key pretty much can be anything, but it's going to be unique when we add elements to this collection. And the value, again, pretty much anything. So the key here in this example is a string, the value is an integer. The variable is called counts. We're initializing it to an empty map of that pattern. And then for some reason, engineering chose to use put rather than add here. We are putting elements into that collection. Here's the key, Acme. Here's the value, which has to be an integer 200. So we have Acme 200, we're adding Salesforce 400, we're adding New Corp 200, and then we're adding Acme again with the value 600. So what's the size of the map? And then down here, we've got what's called a ternary expression that says the count, in other words, the value here, for the key Acme is, and then this ternary expression, remember, this is a shorthand way of writing kind of like if, then else. So it makes a Boolean test here. Is this true? Does the map contain the key Acme? Well, it should do. We've added the damn thing twice. If that's true, get me the value associated with the key Acme. Otherwise, it will return 0. So if I run this bit of code, again real quick, stick it in there, get rid of the old log file. I think that's the right code. We'll see. I may have made a mistake, but who knows? Let's run it. No error. Take a look at the damage. Control E here. The size of the map is 3 elements. The count for Acme is 600. So what will happen here is when we do that, it's basically going to overwrite that. Okay? So it's saying the count for the key Acme is that. That's what it found in that snippet. I hope that makes sense, guys. Right, moving on, swiftly on. So there's a little demo. I've already shown you the demo. Not going to do it again. The sort of the usual conditionals and loops that are available to us here. These are they are similar, sometimes almost identical to what you see in other languages. So again, if you are familiar with the likes of Java and C# and those guys, no mystery for you here. Kind of a weird thing when we're working with Sockle. I'll show you that later. Recently added to Salesforce. Well, not recently, it's at least a year ago, I think. It's been popped in there, but we never had that originally. So we've got some examples here, and it's just different ways of sort of iterating through collections. I think we actually have a little demo here. I might be able to show you this. Let's have a look and see what I've got. So I come back here, come back to my org. And let's see here, conditions and loops. So the ones on the slide, let's plop these in. Try and make this a bit bigger so you guys can see everything. I hope that's clear. So what are we doing? We have an empty list of integers up here. And then we are adding 3 elements, 1, 2, and 3, to that collection. We are figuring out the size, so that should hopefully return 3. And then we're declaring this little variable here, which is an integer. And we've just got a couple of ways of boogieing through that, that collection. So we have a while here. So while that iterator is less than that size, then dump that value out to the debug log and increment the iterator. So this will carry on until that condition is no longer true. Another way of doing it is to use, a for loop here, where you're starting at 0. Whilst that is less than the size, we're iterating it like that, and dumping that to the loop. Or we're actually using this technique. So we're declaring an integer I here, and this tends to be the easiest one, frankly. Unless there's a good reason for it, you tend to use this one rather than anything else. So actually, if I run that, they should all basically return the same thing. So if I do execute that, and let's filter the debug log, and you can see 1, 2, 3, 1, 2, 3, 1, 2, 3. So they're all doing the same thing. The switch statement. Let me pop one of those in. This is fairly new. I don't know if I haven't tested this. Let's give it a shot. So we have some string here with a value, and then we're using a switch on that particular value. And the idea is this is again a nice, easy way of identifying what is the value associated with that. So when it's value 1, do this. Value 2, do that. Or when value 2 or value 3, do that. If it's value 4, do that. Otherwise, do that. So if I run this code, I haven't tested that, so I'm really pleased it didn't give a syntax error. Then you can see it says value 2 or 3. So if I look at the code here, I set it to value 3. That wasn't true, but this one was, because that was true. So that's what it's spitting out. So again, nice and easy to use, but relatively recent addition to the language. So, I'm not going to go on an anymore. They're not going to ask you in the incredibly complicated questions about complex Apex. Platform Developer 1 is not about complex Apex. Platform Developer 2, on the other hand, brace yourself for that one, but Platform Developer 1, not so much. Okay. Let's talk a little about Sockle. We've been going for an hour and 20 minutes here, so I'm probably going to take a break in about 10 or 15 minutes time, because I'll certainly need one, and I'm sure you guys will too. A bit about Sockle, Salesforce Object Query Language. A familiarity with this, let me say that again in English, a familiarity with this is a good idea. You know, they're going to expect you to know this reasonably well. So this allows us to retrieve data, of course, from the database. And actually, I haven't really talked about this, and I've been a little careless. I'm using, you know, you'll see the phrase S objects here a lot. And I've been using the word object as well, and that's been careless of me. I really shouldn't have done that. When we're working with code, we're trying to be precise. You know, when you're working with Apex in particular, you know, you are working with objects. So most things are objects, but not everything is an S object. So by an S object, we mean something you can write to or retrieve from the Salesforce database. So an account is an S object. Opportunity is an S object. Those two custom objects I was messing around with just now, course delivery and course, they're S objects. Because everything can be written to or read from the Salesforce database. And we can have other things in Salesforce which are objects. You could create a class and create an instance of that class. That's an object, but it's not an S object. You could not write that to the Salesforce database or read it from the Salesforce database. So SOCL is about working with S objects because necessarily what you're messing with has to be, you know, in the database. It's used in Apex, it's used in the APIs, but it is not SQL. Okay, if you are familiar with SQL, you've been working with the likes of, you know, SQL Server or Oracle, and I used to work for IBM, so DB2 for me could help me. Then, you know, it's not that. So if you are familiar with SQL, you know, we kind of highlighted some differences here. You know, for example, SOCL, there's only one verb. You can only select that bit, nothing else. You can't select star. So you have to be very specific about the fields that you want to retrieve. We don't really do joins in SOCL. There's no join keyword. We use this dot notation syntax for relationship traversal. And perhaps most importantly, governor limits apply. You know, we restrict in any given transaction how many queries you can do, how many rows that you can retrieve. So governor limits apply here. We'll talk a little bit more about that. What does it look like? Well, the syntax is you have to select at least one field from one and only one S object, and then you can apply other optional sort of clauses here. So usually you would have a where clause. You might have a limit. There are other ones like order by, for example. There's a whole bunch of what we call aggregation functions on the end here. So things like group by cube, group by roll up. We don't think those are going to appear in Platform Developer 1, so you should not really need to know too much about those. They're reasonably well documented, but that bottom line shouldn't, you know, shouldn't. I don't think it's in Platform Developer 1, but the first four certainly are. So the fourth thing you would see, you know, is something like this. You know, you select at least one field. Often you'll put the ID in there. You don't have to. The ID is always retrieved. But I like to put it in because I'm kind of a bit anal about this sort of thing. I want to be explicit. Then, you know, the API names of whatever other fields that you want from one and only one S object. And then I did put a where clause in here, where created date equals today. This is using one of the out-of-the-box data literals in here. So that's the kind of thing you'll see. The where clause itself, again, and it's been a while since I've written real SQL, but I think it's pretty much the same that you might be used to. And most of these are fairly intuitive anyway. Wildcard searches with a like are supported. We use the same wildcard characters as SQL, so the percent for sort of multiple matches or the underscore for a single character match. I think in the these things with pick lists, these guys, they're not part of SQL, so they are unique to SOCL. Logical ands and all that kind of stuff, I think that's pretty much the same. Couple of things to be aware of is if you're working with a date. Okay, so if you are writing SOCL where you're querying a date field, you write something like I'm pointing at here with my mouse. The date has to be in this year, month, day format. and no quotes or anything around it. It doesn't do an, you know, the Americans tend to have this, apologies to any of you who are out there, this sort of month, day, year thing going on, which the rest of the world doesn't seem to subscribe to. So this is what it is in SOCL, irrespective of where you are in the world. It's always going to be year, month, day, like that. If it's a date time, the time aspect is what's actually stored in Salesforce. It's always in universal time, Zulu. So if you want to query a date time field, you know, first of all, the syntax would be something like this. So the date portion, then a T, and then the time portion. And that time is universal time. So if you want to adjust it for a local time zone, like I think this looks like it's San Francisco because they are 8 hours behind universal time, then you do that kind of syntax on the end there. Then there are these things called date literals. So if you are working with dates, don't neglect these things. I do remember being asked this years ago when I did this cert. And I don't think at the time I was particularly aware of date literals. They were a bit of a surprise to me, but it does make in SOCL working with dates really, really cool. There's loads of these things. They're well documented. I think I might have, I'm just going to show you a little, I'm not going to run any of these things, but I was playing around with some of these date literals. So you see this kind of stuff here, down here. So things like today, yesterday, next month, last month, there's dozens and dozens of these things. Or, you know, show me, select me the ID for employee where the joining date is greater than the next 15 days, for example. So most of them fairly intuitive. You don't have to remember all of them, just be aware of them. I do remember some sort of questioning about date literals. And finally, if you're querying Booleans, again, it's just the word true and false. Don't need quotes or anything like that, you know, around it. I hope this makes sense. What else should we do? Now, the fun bit, of course, is dropping your code into your query into Apex. You know, typically what you would do is you'll most likely, if you are building a query, and in terms of what I do, you would go into a tool like Developer Console. It has this query editor tool here. And you might start writing your query in here just to get it, you know, working and get the syntax right. So you might do something like select ID name from, like my keywords in uppercase, but you don't have to. Nothing is case sensitive here, by the way. I don't know. Should we use course? This custom one _ C. What do we get there? If I run that, execute, and there's my guy. Okay, so I can just write it like that. You know, life is good. So obviously, usually your queries are going to be a little bit more complicated than that, but I hope you get the idea. Now, once you've got your query nailed, then if you want to drop it into code, you have a couple of ways of doing it. You can use this square bracket notation. So that's super easy. Just run your query straight in there, job done. That will retrieve a collection of account records. So you need to make sure whatever you stuff it into is going to be a collection of account records. It will be a list. So we declare a variable called accounts. It's declared to be a list of accounts. And that's what we're going to get back. That account between the greater than, less than sign, that word there pretty much has to match what's in your from clause here. So you couldn't, you know, select a bunch of cons from contact and stick it into that variable. The syntax checker would not allow that. The other way of writing it is to use not the square bracket notation, but to treat the whole query as a simple string. So we use the database class and the query method. So both of these code snippets do exactly the same thing. Okay? The difference is that on the bottom one, the query itself is just a simple string, which means that you can build that thing programmatically. Okay? So you have a lot of flexibility over how you build that query if you use this database class here to do that. The downside is that if you mess it up, in the top version, it will detect a bad query at compile time. The syntax checker will tell you, hey, that field does not exist, or that S object does not exist, or you're trying to stuff a list of accounts to a list of contacts or something like that. The bottom one, if you mess it up, it's going to be a runtime error. You'll only find out about any issues when you actually execute the code, not when you actually, store it and compile it. What else to say? If you do want to use the square bracket notation, now we can to some extent make it dynamic via the use of bind variables, and these are available in the where clause in this SOQL query. So something like this, we create a set of strings. These look like case numbers here, and then we say select me from the case S object. I will get the ID and the case number, where the case number is in that set, and we're using that bind variable. So we use that colon notation to denote a bind variable here. So again, be familiar with that as much as you can. One other trick and thing to be aware of, be interested to see if they do test you about this. They may or may not, but you guys need to know either way. If you are selecting from an S object, if you select into a single variable, not a list on the left-hand side, notice, but a single record. So we declare the variable of type account, and we're selecting ID name from account where the name equals Acme. Now, what you're telling Apex here is I 100% guarantee, no messing, that that select statement will retrieve exactly one record. If it retrieves more than one, or if it retrieves 0 records, you're in trouble. You will actually get what's called a query exception, a runtime error, which if there was nothing coming back, you'd see, hey, the list has no rows. Or if there was more than one record coming back, you'd see, hey, the list has more than one row. So usually you would always select into a list, which will always work. If there's 0, 1, or many, providing you don't blow any gun limits and stuff like that. Make sense? Now, we'll talk about this and then we'll have a break, because this might blow your minds. There's a sneaky thing you can do with SOQL. You can, if you're going to write a query, you're often going to want to process the results. It's going to retrieve a collection, and typically you would loop through that list of stuff using one of those loop counters that we talked about, for loop, for example. But there's this sneaky thing called a SOQL for loop with implicit batching. So you have to write your query, your code, exactly like this. So on the code I've got on the screen here, on line 1, I have a for loop. That the iterator, that's the thing on the left of the colon, is not a single S object. It's a collection. It's actually a list. See here? So if you write it like that, on the right of the colon, you put your select statement in there in square brackets. What this will do is it will enable a batching mechanism to kick in. There's this magic number in Salesforce, this number 200, that pops up all over the place. And it pops up here. So what you can do is you guarantee that the maximum size of that cases collection is 200 elements. It will never be more than 200 elements. But you may go through that outer loop more than once. So, for example, we're trying to show you on the slide here. Let's say that select statement retrieve 403 records from the case S object. So what will happen is it will get the first 200, stuff them in there, and then inside the loop, you might have another loop, which will, like an inner loop, which will iterate through that one record at a time. Then we'll come back and we'll get the next 200 and do the same thing. And actually it will carry on until it exhausts the results of the query. So you would see in this particular use case that outer loop would execute 3 times. 200 elements, the next 200 elements, and then the final 3 elements up here. Okay, so that's a SOQL for loop with implicit batching here. Doesn't affect the number of selects you do, doesn't affect the total number of rows you retrieve. It's only use is to basically deal with the results of that in manageable chunks, in batches of no more than 200 records. You can't change that number. Okay? I hope that makes sense. And they do like to throw stuff like that into the cert because it's kind of a little bit weird and it's quite unique to the way Apex and Soccer works. Okay, so I tell you what, I've been going for an hour and a half here. I'm sure your ears may be bleeding from my voice. So what we'll do is let's take a short break so I can get another cup of tea and have a comfort break. And I suspect you guys might need one too. So what I'm going to do here is I'm going to set a little counter on the screen. Let me try and do this. I have a little stopwatch thing going here. This little fella. Let's make it really big. And let's just take a 10-minute break. So I'm just going to set a countdown here. And I will start again when that gets to 0. So stay online, guys. Stay connected. I'm just going to go on mute and go and get a cup of tea. But I will leave everything running. And I will start again in 9 minutes, 49 seconds time. Give us a chance to have a cup of coffee or a cup of tea. Okay. Talk to you very soon. Okay, I'm back. My little counter's just needed. I'm just going to stop this because it makes a horrible noise when it gets to the end there. So I'm back. I hope you guys are too. Welcome back. We will soldier on through the wonders of Sokol. I hope you've all managed to get a drink or refreshment. I know I have. My wife kindly made me a cup of coffee. So let's carry on. Still talking about Sokol here. Now, I mentioned this earlier when we were talking about formulas. This deal with relationship traversal. You know, when we have formulas, we have those little buttons to help us out. But in Sokol, we don't. So when you're writing these queries, an understanding of the syntax and how all this works is important, because they will almost certainly, at some point, you know, validate this with you in the certification exam. So let's say here we have two standard objects, count and contact. As you hopefully know, we have a one-to-many relationship between these two little guys. So I've drawn this out on this picture here. And you can see here that I have a parent account record, and I've just made up an ID 123 here with the name account 1, and it has a single child contact record ID 456. And this is the structure. This is how it actually works. So you can see the relationship field here, which is actually called, the actual name of the field is called account ID. So remember, this is a standard relationship. This is always there out of the box. So what I want to do, let's say I'm querying from the child here. I'm selecting from contacts. I'm selecting the ID of contact record. I'm choosing account ID, so that will give me the ID of the parent account record, 123. And then I've got account dot name. So this is the dot notation syntax. This is relationship traversal. So what that actually means when I have the word account dot in there is it's giving me access to the parent record, and then dot name lets me retrieve a specific field from that. Okay. So that's the standard syntax. That's standard objects, standard relationships. In the custom world, it's the same thing, but it uses this different naming convention, and sometimes this can be difficult to sort of get your head around it a little bit. I have two custom objects here with a custom relationship between them. Same kind of deal, parent-child. I'm selecting from the child. So I'm selecting from course, underscore C. I've got my child guy going on in here, so I'm selecting the ID of the course. And then there, certification underscore C, that is the name of the foreign key field. That's the name of the relationship field. We have a lookup relationship from course to certification, so the name of that field, by default, is the same as the S object it's pointing at. So certification underscore C here is going to give me the ID of the parent record. If I want to retrieve anything else, I have to do that relationship traversal trick. So certification underscore R, this guy, R for record, give me the record, give me the parent relationship record, and then dot name would retrieve cert 1 on that thing. Okay. Difference from formulas is that this trick you can only go up 5 levels. Formulas up 10. Sokol up 5 using this technique. Okay. Other way around, which you cannot do with a formula, but you can with a Sokol query, is to start at the parent end and reach down. So in this example, I am selecting from account. You know, again, I wanted to show you standard and custom here. So we have a standard object, standard relationship. I'm selecting from the parent account. I want the ID and the name from the account record. And I can also retrieve in the same query the children. I have a subquery here. It says select ID from contacts. And notice the plural form here. So this is another use of the plural in this example. And what that does, it reaches down to the collection of child records and retrieves that lot. So I would actually get the ID and only the ID of each contact record, all in one query. Same thing in the custom world. Now I'm selecting from the parent certification underscore C and attempting to retrieve its children. So I've got ID and name from certification underscore C, and then the subquery. Notice again, this is the other use of that plural name that you give it. Remember, when you create an S object, you have to give it a label, which is cosmetic. You give it a name, which is used to generate the API name, and then you give it a plural. Okay? And this actually uses that plural name in here. So course is with an S underscore R gives me the collection of child records, and then for each one of those, in this particular example, I'm just getting the ID in the subquery. You can only reach down like this one level. So formulas, 10 up, can't go down. SOCL, 5 up, from child to parent. But you can go down one level, which you can't do in a formula, but you can only go down one level. You can't reach down any further. I hope that makes sense. So often this is difficult to get your head around, and people do struggle with this a little bit, and they do like to throw this kind of stuff into certification exams occasionally. So make sure you're as comfortable as you can be with that. All right, so that's what I have to say about SOCL. SOCL, a search language, a bit simpler. Not too much to say about this, but very, very different syntax. We don't do a select, we do a find. So this is what a SOCL search will look like. What happens is when you add a record, you insert a record into Salesforce, or maybe you update an existing one, and providing you've allowed it, any text, email, and phone fields are submitted to a full text indexing engine. So what happens, it actually tries to build separately indexes on these fields. And when you do a find, when you do a search, you're searching those indexes for hits that correspond to whatever text string that you are looking for. This only works on text, email, and phone fields. In particular, it does not work on pick lists. So although you might have a pick list with just text values in there, you ain't going to be able to search for them. Okay? Pick lists won't work, but all the other forms of text field, not encrypted, email and phone fields, they can play in this game. So the syntax is going to look like this. You have the search string in here. So this is find me the string Acme. Then you've got an operator in all fields. In other words, can you search all text, email, and phone fields? You can limit this to say in name fields, in email fields, in phone fields. You can make that a bit restrictive, or you can completely leave it out, which is the same as saying in all fields. And perhaps very, very different from a SOCL query, you can return records that belong to multiple S objects, and that's defined in the returning clause here. So that search there would say, find me the string in Acme in any text, email, and phone fields, but I'm only interested in records belonging to account and opportunity S objects here. You can have one S object in here, you can have a whole string of them in here, but it will only retrieve records that belong to whatever you put into the returning clause in this example. The fun bit is that it comes back into this weird structure called a list of S objects. So it's using the superclass here called S object. And we need to do that because you may be returning records from different S objects, account, opportunity, course, underscore C, whatever you kind of shove in there. And they're all different S objects, but they all belong to the same superclass. So we can add that in here, and that's the form that we get this thing back in. So the fun bit is really kind of interpreting the results of the find. Turns out that's fairly straightforward, and I've got a good example of it here. So in this bit of code, we have at the top here a find. Find me the string Acme in all fields. Notice there's no in all fields in here, so that basically means the same. If you leave it out, it means go to search all text, email, and phone fields. But I'm only interested in returning account and opportunity records. From each one of those, I would like the ID, which you will always get, and also the name field. So like kind of SOCL, you have to be fussy about the name fields that you retrieve. And that will come back into a list of S objects, which we call ACMEs. So when you want to parse this out, when you want to interpret the results of what you get back in your code, you do it like this. You know, the first element, ACMEs 0, is going to be a list of accounts, because account is first in the returning clause. The second element of the outer list, ACMEs 1, is going to be a list of opportunities, because our opportunities is next in the returning clause, and so on and so forth. If there was only account in there, we'd have ACME 0 and we wouldn't have anything else. So it actually turns out, I think, to be fairly easy to sort of interpret what you get back from a find, but it will always be a list of S objects. Okay. Moving on, where can you use SOCL? Well, again, it's used in Apex, it's used in APIs, and kind of a bit like SOCL, you can use the square bracket notation, or it's not database, it's the search class .query this time, and you can just then use your find as a simple string, which of course means you can, format programmatically. One little tip: if you do that, the string that you're searching on, if you're using the search.query, has to be between curly braces and not single quotes like it is for the square bracket deal. And you can also use bind variables in here as well, like I showed you at the bottom of the screen. So what else we got? So that's kind of what I have to say about SOCL and SOCL. DML. So SOCL and SOCL are about retrieving stuff, but DML is about shoving things back in, of course. Data manipulation language. These are the options we have available to us: insert, update, upsert, which is like the love child of the first two, delete, undelete, and merge. There's other ones as well, but these are kind of the ones you most usually use. Maybe not merge so much. So I've got some scenarios here. I'm just going to quickly talk through these. So let's say you wanted to retrieve into memory a contact whose lead source is trade show. Modify it to other and persist this modification back to your org. So this sounds like an update to me. We want to get a record, mess with it, and update what's in the server. So update or upsert. Now, upsert is either an insert or an update. It matches on the Salesforce ID. So whatever records you feed an upsert, if it has an ID, it's going to do an update. If it doesn't have an ID, it's going to do an insert. In this particular case, either update or upsert would work for scenario 1. Scenario 2, create a new instance of the contact in memory and persist this instance to your org. Well, that's going to be an insert or an upsert. Again, both will work equally well here. Number 3, users who were incorrectly entered as contacts through the UI retrieve those contacts to memory and use their ID values to remove them from the org. Well, obviously that's going to be a delete. Remember, when you delete a record in Salesforce, it's a soft delete. It moves it to the recycle bin where it will stay for anything up to 15 days, although maybe sooner, because there's a storage limit from there as well. But it's really a soft delete. There's a hidden field on every S object called is deleted. So it really just sets that hidden field to true. And that's the thing that sends it to the recycle bin. What's the fourth one? Create new contacts in memory, modify existing contacts. This is a single command to persist new and modify contacts. Well, that's got to be an upsert, because you want to do a combination of insert and update. So upsert is really the only way to go for number 4. And the last one, you actually did the delete. Oops, didn't mean to do it. So they were removed, but they were created correctly. Use SOCL to retrieve those contacts from the recycle bin into memory and then restore those contacts. So that's going to be an undelete. But of course, if you're going to undelete, you need to know the IDs of the records you want to undelete. So you have to query those first to get the list of IDs, and then you can just undelete them. That's the deal. Now, when you write code, kind of like SOCL, there's two ways of doing it, and we've got two code snippets here, which actually are exactly the same in their behavior. What this is doing is we are creating a contact called withName, and we are setting the last name field of contact. Now, last name is a required field, universally required on the contact S object. Then we're creating another contact called noName, and we're simply initializing this to an empty contact record, and we are creating an empty list and adding both contacts to the list. So you've got withName first and noName second. And then we are simply inserting the list, just like that. So this is called an all or nothing transaction. Either everything works or nothing works. And because we have a bad contact in there, the database is not going to be happy with a contact called noName because it does not have a required field set. So the database will reject that transaction. Nothing ends up in the database. And it's exactly the same on the right-hand side here. The one on the left, this is called a standalone DML operation, just with the word insert. On the right, we're actually using that database class again with its insert method, but we're feeding it the same list, and we'll get exactly the same behavior. Now, if we do one thing and one thing only, we can affect that. If we use the database method, database.insert in this example, same list, with a good contact and a bad contact, but we set the booleans, a boolean flag on the end. If we set that to false, this enables what's called partial commit, which means the good record will make it to the database, but the bad one will be ignored. So if we use the example from that code on the right-hand side here, withName would actually be added successfully to the Salesforce database, but noName wouldn't. Doesn't throw an error, doesn't break. We can get the result from this back. We can figure out what went on, but it doesn't, it doesn't break. It's a partial commit. On the left-hand side, all of these options are all or nothing. So if you use the standalone DML, if you use database.insert with no Boolean, or if you use database.insert with a Boolean set to true, these are all the same behavior. It's all or nothing. Only when that Boolean is set to false, it's called the all or none parameter, do we get partial commit kind of behavior. All the ones on the left-hand side would throw a DML exception if we try to run it. Okay. Here's some code blocks for your enjoyment. So again, this is just to point out some of the things that can go wrong. Sorry, I'm just having a slip of coffee here. So the top one, we create a list of contacts. It's an empty list. And for some reason, best known to ourselves, we are attempting to insert that empty list. What happens here? Nothing. There's no error. Nothing happens. Apex figures out that, well, there's nothing to do. I'm not going to do anything. Just going to move on. So no exception in this particular case. The second one is what we've just been talking about. I've got an empty list. We're adding a contact to the list, and that contact is a bad contact, essentially. This is an all or nothing transaction. We're going to get an exception here. So we need to make sure that all, required fields are populated if we're going to do this sort of thing. This is an interesting one. We're creating an empty list. We're creating a good contact because we are assigning the last name. We're adding that to the list. And then for reasons best known to ourselves, we are setting the first element of that list to null. And we are inserting the list. So unlike the example at the top here, where this is an empty list, this is essentially a bad list. Okay? So this will actually throw an error. We've got a list exception here. Basically Apex is unhappy. So hang on a minute, that's a dodgy list. What the hell are you trying to make me do with it? The top one, that just says, that's an empty list, don't care. But this is a bad list. So this will actually throw an error. Then down here, whoops, got a bit carried away. We've got a loop, 175 iterations by the look of things. Inside there, we are creating a good contact with a unique last name each time. And we are inserting that contact. And rather helpfully, it tells us that there is a governor limit for the number of DML commands in a single transaction, and that is 150. So this will work 150 times, and then on the 151st, it will all blow up and die and go to hell. So nothing will, this is all or nothing, nothing's going to be inserted here, it's just going to break. And finally, down here, we've got a empty list of contacts. We have a contact with a very long last name, 85 characters by the look of it, which we were adding to the list, and then we were inserting it. And it tells us, hopefully, that last name is a text 80 field. So obviously here, it's either going to truncate or it's going to fail. And actually, this is going to fail. So this will also throw an exception if you try to do that. So lots of ways to break stuff, in this example. Now, when you do work with exceptions, you can catch many of them. We have the concept of a try-catch structure, actually try-catch finally, which, as far as I can tell and remember, works pretty much exactly the same way it does in Java, the likes of Java. So if I kind of run this little bit of, actually it's probably easier for me to run a little coding snippet here. So let me go find my little code snippet and see what we've done here. Let's bring up my org. Here is developer console. Let's go into the anonymous window, get rid of the stuff that was already there, and pop this in. I think this is pretty much similar to what's on the slide. I tweaked it a little bit, actually. So let's see, what are we doing here? We are creating a list, an empty list. We're adding 3 elements to the list. We are getting the size of it, and we are trying to reference the 4th element here, that example. And then I have the whole thing there is inside a try block. So basically it will try that, and if there's an error, we can try and catch that error in one or more catch blocks. You can have multiple ones in here. You can try and catch different exceptions. And there's probably 20 or 30 different sorts of exception that are going to be available to us. Things like, and I just put 3 of them here, a null pointer, or maybe a list exception, or maybe that's like a catch-all, that one there. There's also the concept of a finally block. So this will always execute whether or not an error occurred. So if I run this, and we take a look at the debug log, and let's bring the code up again, you can see that there was a list exception. So it's actually that one that happened. But you can also see the finally block executed as well. You know, now you tend to use these guys if you want to catch specific exceptions. If you don't care, you know, what exception actually happened, you just want to know whether it was good or bad, then you don't necessarily need to have multiple catch blocks. You could just do that, for example. So if I run this again, now it's going to open up another log file, which I'm going to filter. Then you can see, yep, we did catch that exception, but it was caught by the sort of the general purpose tool here. We're not too fussy about the nature of it. We just want to know whether there's an error or not in our example. So as I recall, you know, and finally still executed. So as I recall, you know, it works in pretty much the same way. If there is no exception, then you do this sort of thing. So for example, if I comment that line out and run this, you will still, even though there's no error, you are still going to see that finally block. You know, this thing here, it's always going to run, irrespective of what's going on up here. The only thing to be aware of is you cannot catch a governor exception. So if you do too many queries or retrieve too many rows or do more than 150 DML statements, it's going to throw an exception, and you can't catch those. It just breaks. It dies and goes to hell. So you cannot catch governor exceptions. And actually, when I talk about it, I suppose, actually I think we have a slide later on, so I was going to show you where to look up these governor exceptions, but I think that actually comes in a little bit. So I won't do that here. So, in fact, it comes here. So, the reason I'm going on about all this governor limits is really because of this. You know, these limits are what we apply to your Apex code because of this multi-tenancy. And you have to be really cognizant of what the hell is going on here. You may have written a bit of Apex code like I just did. You know, maybe I just ran that from execute anonymous. I didn't do very much in my one, but maybe I would have perhaps invoked a method in a class. Maybe that method actually did some sort of DML. Maybe it did insert a contact record or something. Maybe I had automation on contact. Maybe there was an Apex trigger. Maybe there was a process or a workflow that was configured to run when you ever insert or update a contact record. That whole thing is considered to be what's called an Apex transaction, a single unit of work. And that's what we apply these things called governor limits to. These are hard limits. If you hit one, it doesn't end well. You cannot catch these things. The sort of thing we constrain are, and most of these on our per transaction basis, are things like the number of queries you can do, the number of DML database operations, the amount of memory heat space you can consume, the amount of CPU time you can eat. And it applies to the whole thing, not just the little bit of code that I just ran, but any downstream effects that I might have initiated, and that's controlled by something called the order of execution. So these governor limits are what rule your lives as an Apex developer. If you hit one, it's going to be bad. So your job is to not hit one as an Apex developer. They're pretty well documented. So I can see if I can find the link here just to show you where these things are. I've got it bookmarked here. Just bear with me a second. Could have opened this earlier. There we go. Governors and limits. So this is a page in the Apex Developer Guide. So you don't know where this is already, you pretty much should do. If you go to developer.salesforce.com, look under docs, all documentation, you'll find the Apex Developer Guide there. And there's a page in here where they do talk about execution governors and limits. And it's going to spell out what those limits are. There's quite a few of them on this page. You really don't need to know all of these. And I used to think they would never test these in the certs, and I think that's changed. So kind of committing the main ones to memory is probably a good idea. So for example, how many SOCL queries can you issue? 100 in synchronous Apex. How many rows in total can you retrieve? 50,000. There's the DML limit, 150 DML operations. The number of rows you can affect with those DML operations, 10,000. So probably this first chunk up here, you should know, okay? Or you should know it anyway if you're going to be doing Apex development. But for the purposes of the cert, probably don't have to remember all of them, but the first, the ones that really relate to SOCL, SOSL, and DML, I would make sure that you kind of have those in your head when you do the cert. One of my colleagues actually doesn't like to call these governor limits, he likes to call them efficiency limits, because basically we force you to write efficient code. If you don't, it's not going to end well. So you have to write efficient code to be able to get it to work on Salesforce. A little bit of a demo. Let's have a quick look, just to show you an example. Let me just find my little code snippet. Pop this into my org here. So let's go back. Let me close these tabs. Let me go back into Anonymous. Let's get rid of that. In Apex, we give you this limits class. And for every governor limit, it has two methods. One that gets what is the current governor limit and what is your consumption against that limit. So for example here, we've got get limit queries. How many queries are we allowed to do? Okay. So from that document, that should return the value 100. Then I've got a loop here and inside that loop is looping 100 times, and inside that loop, I'm running a select statement. I'm running 100 selects. And then down here, I'm saying, well, okay, how many have you done currently in this Apex transaction? So get queries, get limit queries. So this will return how many have I done. So if I run this, and I look at the code and the debug log, there was no error, and I'm allowed to do 100, and I actually did 100 in that example. If I push the value over the governor limit, so if I go to 101 here, and I rerun this, I get that. So that is a governor limit exception. Too many SOQL queries, 101. And I cannot catch that. Okay, so my code there will break. There's nothing I can do about it. So I should strive not to do that. And actually that limits class, this is the tool we will use to do that. If you think, you might be getting close to governor limits, you can actually ask the question before you do this, do I have enough governor limit left in this transaction to be able to do what I need to do? And if you don't, you just basically don't do it. Okay so far? Good. All right, so staying with these governor limits, it's important. This example here, we have a for loop. We are iterating through the results of a query, one record at a time. And we are doing absolutely the worst thing you can do in Apex, which is we are running a DML statement on a single S-object record. Okay. So, number of selects you can do, 100. No problem here. Number of rows you can retrieve, maximum 50,000 without blowing the limit. Okay. Okay, so that's quite a lot. Number of updates we can do, 150. So you wouldn't have to retrieve very many records here to blow this particular governor limit. So that's just like absolutely a red flag if you saw any code like that. Any sort of DML operation on a single S-object record, it's going to be bad. So to mitigate that, this is the kind of thing you look for. The same kind of stuff, or same query, same for loop, but inside of here, we are basically adding the records we want to update to a list, and outside of the loop, we are doing a DML operation on that list. Okay? So again, this won't change the number of selects or the number of rows, but it will change the number of DML operations. That will only do one in this example. We still have to worry potentially about the number of rows we're updating. There's a limit of 10,000 there. So this thing did return more than 10,000 rows, and we wrote it like that. When we came to there, it's going to blow up. Okay. Now, you could mitigate this using this weird SOQL for loop with implicit batching. So if you remember this from before we had a coffee break, if you write the for loop with that iterator as a list, you've got this batching mechanism kicking in. So the maximum size of that list is 200 elements. So down here, if you're going to chew through those and do whatever you need to do to that batch of 200, and then we update that batch of 200, and then we go get the next batch of 200, and we carry on. So this does help a little bit, but it doesn't get you out of jail. If you think worst case scenario here, how many rows could you retrieve in that select without hitting a limit? 50,000. You're going to chew through that in batches of 200. So 50,000 divided by 200 is 250. So worst case, 250 iterations of that outer loop, but only allowed 150 updates. So it doesn't get you out of jail doing that kind of trick. All it really does is limit the size of that list. Helps with memory, but that's about it. So that's that first chunk here. I need to pause for a minute. So I'm just going to go on mute. I'm only going to be away for a minute, so then I will come back. So I'm just going to be quiet for a minute here. Okay, I'm back. Apologies for that. Too much tea and coffee. You probably didn't need to know that detail. So let me just find out where we are. Let's move on to the next bit. Still in this sort of process automation and logic section here. So we want to talk a little bit more. That section was really about sort of the basics of Apex, so the language, talking about SOCL, talking about SOSL, talking about DML. So this next bit, if you like, is putting it into practice. So, working with classes and triggers, for example. What are the implications of governor limits on Apex transactions? So some scenario-based stuff. And particularly things like the save order of execution that we want to cover here. And that is important that you guys know, what's going on when you hit the save button. So a little bit about classes. Most of your Apex code is going to end up in an Apex class. Maybe, I don't know, 90-odd%, most of it is going to be in a class file. So they're the workhorse, if you like. We use classes to hold your business logic. We'll use it for testing. If you're using Visual Force with controllers or controller extensions, that's another class. General utility methods. There's numerous use cases for class, and we're not by any means have a complete list here. For example, you can use classes for exposed methods as web services or email services, which we're not really going to cover. That's really not part of Platform Developer 1. You would see stuff like that in Platform Developer 2. So Apex, like most OO type languages, does have an inheritance capability here. They may ask you some very simple questions about this in the cert. We use interfaces and virtual classes. So I'm just going to show you an example here, which really I've just, shamelessly stolen from the documentation. So I'm hoping that what I talk about here will cover whatever they might ask you in a particular certification. So I'm just going to show you my example. I'm just going to show it on the screen here. So I took this from the documentation. So first of all, interfaces. So an interface is kind of like defining a template for what a class, when you create a class itself, should look like. So here we're creating an interface called purchase order. And in there you define one or more methods. Now you don't define what the method does. All you define is what it will return to you. So you're saying this interface has a method called discount. It must return a data type of double. In your class then, down here, if you implement that interface, and you can implement more than one, that means in your class you must create a method called discount. It must return the value of the double. What it does in here is up to you. Okay? So you could have multiple classes, like here's another one, that implements the same interface. It has to implement that method, but the implementation, is going to be different. So interfaces are actually quite straightforward. That's it. They're kind of like a template for a class. This is what it's going to look like. You've got to implement these methods. They've got to return these data types. You can have more than one interface when you define the class if you choose to. Virtual class is a little trickier. So again, this is the example from the documentation, which I shamelessly stole. So we have a class called marker here. It's got some methods, 3 of them, called write, discount, and hello, like that. Just a regular class. You can just treat this as a regular class. You can create an instance of this class, and then instance.write or instance.discount or instance.hello works in the same way that all other classes work. However, because you've marked this as virtual, and also the same thing for these 2 methods here, we can do this. You can create another class that extends this guy, extends marker. And you can then override methods in marker with your own version of it. So in the example here, we have a public virtual class called marker, and we have another public class called yellow marker that extends marker. So what this is doing, this is the actual bit of code that you might think about running. Let's say down here, we create an instance of the marker class, that's this guy. And we do instance.write. So we're just going to call that. So you would see that spat out to the debug log if you run this. Great, as normal. Okay. Then down here, we're creating another marker object, but this time we are using yellow marker here. We're allowed to do that because yellow marker extends marker. Okay. So object 2 is an instance of yellow marker. This time when we do that, we don't execute this, we execute that, because this write method overrides the one in the marker class here, like that. Okay. If we did object2.discount here, okay, we will actually get that the instance, the method it will run will be the one in the marker class, like that. Okay. That's pretty much what you need to know. If we did hello, we're going to get the one also in the marker class up here. Okay. If we did opt2.compute price, we get this guy down here. That's pretty much it. And that level of knowledge is probably about good enough for any vile, certification questions about things like inheritance interfaces, virtual classes. To do that trick, you must mark the class as virtual, and you must the same thing for the methods that you want to override. In the yellow marker, you must extend the virtual class, and then you can override any of the methods that are in there. Now, what do classes look like? We've touched upon this a little bit. They'll have an access modifier here, which is there's no default. It has to be, you have to supply that. There's the with or without sharing keyword. We'll talk about that. And then in the body here, you can have class member variables. You can have properties with getters and setters. You can have constructors, one or more, taking different arguments. And you can have methods, of course, in here. So, you can pack all these things into classes. And then they're pretty much the same that you would tend to see in other languages, I think. So again, it will benefit to you if you know about Java and C#. If you don't, that's fine. This is actually not too complex. And I wouldn't expect anything too scary about this sort of thing in Platform Developer 1. Now, these access modifiers, the access modifiers is what we mean here at the class level and also at the individual sort of class member level here. There's 4 possible ones. At the class level, there's actually only 3. Global, public, private. There is no default, so you have to supply one of those when you define a class. Usually it will be public, which means the contents of your class is available to other code within your namespace, but any other code that you write in your org. So typically you make most of your business logic will be in classes that are public. You would use global if you want to make the methods in your class or the contents of it available to code in another namespace. We'll talk about that in a second. Or if you want to expose it as, if it has methods in there like exposed as web services or email service, where you're calling into your class from outside of Salesforce. The class itself must be marked as global. The other option is private, which means you can't reach into the class at all. So test methods, for example, test classes rather, are usually marked as private. Protected is an option that's not available at the class level. Namespace prefix. These guys are used to distinguish your code from any code that you might have installed in a managed package. I don't know if we've got an example of that. Let me just have a look in the org that I'm using here. Let me just come out of Developer Console. And let's have a look. If I look in my org here, and let's have a look at the Apex code, the Apex classes that are in here. So I've probably got quite a few, as these guys. So you can see here quite a lot of Apex classes in my org. And I've got this thing called namespace prefix, and it's all empty. Because all these belong to the system namespace. It's always implied. It doesn't say system in there, but they're all in the system namespace, because it's stuff I've written. But I think down here, there are two classes which have a namespace. So SFU, what we call Salesforce University, before it became Trailhead Academy, Knowledge Check Manager. This is a unique, we used to have we'll still do sometimes, a package that we installed into our training orgs, a managed package, and that contained a couple of Apex classes. Now, the problem we might face is maybe I might, in my org, have created a class called quiz redirector _ test. Class names have to be unique within a namespace, so I could not have two classes in my system namespace with the same name. But this was installed from a managed package, and managed packages get to create a unique namespace. So this class does not belong to the system namespace, it belongs to the SFU KCM namespace. So I can actually have a class in my org with that name. It will be allowed because it will be in a different namespace, this guy here. These classes are protected because they're installed from a managed package in a different namespace. The developer, whoever wrote it, allows me to use these things, but I can't look at them. If I try to go into the code here, it just says, nope, you can't do that. That code is not available to you. So the intellectual property, the idea is that the intellectual property of that stuff is protected. Then for class member variables, all four of these things are available. So you might have a global class with public methods. You might have a public class with public methods or private methods. You can't make the contents more accessible than the class itself, though. So, for example, you could not have a private class with a public method. That would not be allowed. Other way around, good. But you can't make the contents more accessible than the actual class itself. The only other bit in here, which sometimes is a little tricky, is what does protected mean? Don't know if they're really going to drill you with this in the exercise, in the certification. Might try and show you a simple example here. I'm just going to rough this out in a text editor. So let's say you have a class public. I'm going to be typing here, so don't judge me on this. Public class my class. Something like that. There it goes. This is just pseudo code, so this isn't going to be super efficient. And let's say I have a private string, my string in here, okay? And let's say I have a method, public void my method, like this. Now that method can access that private string. So the method could quite happily do my string equals, and at some point in any sort of programming discussion, you've got to have the word hello world in there. It's kind of like a legal requirement. So that would be fine, okay? But I could not set the value of that directly from outside of the class. If I created an instance of this class, I couldn't do instance.iString because this thing here is private. Okay? But what I can do is I could create an inner class in here. So I could have public class, let's call it my
Hi, Nika. How are you?
inner
Good,
class.
how are you? Good. We're just giving everybody just a chance to join the call.
So define a class within a class. Yeah, quite acceptable, we can do that. Sometimes because we, for convenience mechanism, we might want to do something like that.
Sure.
And that inner class might have a method called public void my inner method. Something like that. Whoops.
Good morning, Nika. Good morning.
Okay. Now that
Good morning, good evening. We
inner
literally
method
are on both sides. 6:30 in the morning here, 6:30 in the evening there.
You can't do that. That would not be allowed. And that property there is private to this class, but it's not. This one can't see it, even though it's defined as an inner class inside of here. It cannot see that guy. If I want to allow it to see that guy, still keep that one sort of within this whole structure, not make it available to the outside world, I would use protected like that. In this case, that would work,
on the time
that
when
would
someone
work,
says
but I
something
still can't set the value of
than
that
what we
outside
think it
of
is.
this class. So I hope that makes some sort of sense to you guys here. I don't know if they really drill down like that in the certification. Be slightly surprised if you a mean day for the examiner if they actually ask a question like that. But just so you're comfortable with how that actually is. And remember that is not available at the class level.
I think they are
okay, what else we got? Security. Again, super important. Make sure you are comfortable with security. When you create a class, as a best practice, you should always use either with sharing or without sharing. You might possibly use it. With sharing means whatever code you run in that class, it's going to obey the sharing model for the current user. Without sharing means it will ignore the sharing model. Remember, your Apex code is running in system mode. And inherited means it will inherit the behavior of whatever the calling class. You're calling a method in this class from a method in another class. If you leave it out, then you can get some ambiguous behavior, and sometimes as a developer, people look at your code and wonder, did you leave that out deliberately, or did you leave it out, by accident? So if you wrote code like that without any of that stuff in there, the behavior of the code in here is going to depend on what calls it. So if you had a method in that class and you were calling it from execute anonymous is user mode. It obeys the sharing model. So with the method in here. If you call that from an Apex triggers are fully system mode. So any methods in here would ignore the sharing model. And then if you call this thing up here from another class, if the other class respects the sharing model, so would any methods in here. If the other class ignored the sharing model, so would any methods in here. Okay, so just be sensitive to the way that is designed to work. The other thing you have to worry about is object and field level security. These things up here with sharing, without sharing, or whatever, they take care of record sharing, but that's only part of the security model. There's object security and there's field level security to worry about. And most of your Apex code, unless you're running it directly in Execute Anonymous, is fully system mode, so it will ignore object and field level security. If you don't want it to ignore that, you have to sort of code that in. And there's a number of ways of doing it now. When you're writing a query, then you might have that keyword in your query called with security enforced. And that means if the user who's causing this method to execute, and this is actually one that's coming from a Lightning component here, but it doesn't have to be. Let's say they don't have access to that field, that social security number field. If you've got this switch and the user does not have access to this field, this select statement will throw an exception. So really, if you're going to write it like that, you should actually put this thing inside a try-catch block, so you can sort of gracefully catch the exception. So if they don't have access to any of these fields or to this object, it will throw an error if you actually put that switch in, which you should catch inside a catch block. This is only available in Apex code. You can't write a query with that in there, by the way. So that would help a little bit. And I think only a couple of releases ago that appeared. Something that's even more recent is this strip inaccessible, this security strip inaccessible method. Not sure they're going to have this in the cert, but the cert's recently been rewritten, so they might do. I would if I was them. So in this example, we have we're doing a query. So let's again postulate the user who's causing this code to run does not have access to that social security number field. So when we write this query, that's going to work. So this list of contacts is going to contain records with that field that's in there. We don't have that with security at all. But what this strip inaccessible method allows me to do is I can take that list, throw it into this method call, say I need at least read access to the stuff that's in there. And what it will do is it will filter out any fields that the user does not have access to. So this decision collection here will contain the same set of records, but they won't contain the social security number. So if I dumped these things to the debug log here, then if I use my contacts, you're going to see the social security number. But if I use decision.getRecords down here, you will not see the social security number. It will filter out those inaccessible fields. And you can also use this when you do things like DML operations. So again, you can use this to filter out stuff that the user doesn't have access to before you do a DML operation. So I think this only became GA relatively recently, but it might be in the test. So worth knowing what this thing does. The final way, and this is the way that's worked for years, is to use getDescribe. So basically ask questions to the schema. Does this user have access to this object? What level of access? Does this user have access to this particular field, or this particular S object? So using getDescribe methods, this has worked for years. This is the way we've usually done this kind of thing before we have those two other options available to us. So I believe there may be questions related to this in the cert. So make sure you're comfortable with this kind of stuff. Right, enough about classes, but about triggers. So remember, Apex triggers, this is code that is run automatically whenever a DML operation happens on an S object. So insert, update, delete, or undelete. We don't have an explicit upsert in here because an upsert is either an insert or an update. The important thing here is to realize that when you save a record, let's say you're either inserting one or maybe you're updating an existing one, you hit that save button. You're entering this thing we call the save order of execution, which we'll discuss in a bit more detail in a minute. But the important bit for now is that journey from sort of screen to database takes place in two stages. The record is saved to the database at some point. So it's actually written to the database, but here it is not visible outside the scope of this order of execution. So Simon, if I was actually doing this, if I was saving this record, it would enter this order of execution, that all these blobs actually mean something. And it hits that save point. It's written to the database, but none of the rest of you can actually see that data yet. It's only visible to the outside world when we get to the final commit point. Once it's been committed, the rest of you can be able to see that. You will be able to retrieve it in queries and stuff like that. So there's always this sort of two-stage journey. And that allows us to inject code at 2 points in this order of execution, before the save happens or after the save happens. So these are what we call before triggers, the green ones, or after triggers, the purple ones here. Okay. So they have two sort of use cases. It's code, so you can do anything you damn well like in either location, because it's just code. But typically, before triggers, they're sort of used to do more sophisticated validation. You've got custom validation rules, which are based upon a formula where you can make some sort of test, and you can say, well, is this field or this record or whatever valid or not, yes or no? And if it is valid, you let it go on its way, and if not, you stop it there and send an appropriate message back to the user. Before triggers can do exactly the same thing, but of course it's code rather than based on a formula, so that the validation itself can be much more sophisticated. You can refer to other objects, for example. And you also have the option to change the inbound data. So you can't do that with a formula, with a validation rule. So you can actually change the content of the inbound data if you need to update your record values. After triggers, they occur after the save. So they're typically used if you want to do something that's related to the record that's being inserted or updated. So let's say you are inserting an account record, and you want, as part of that transaction, to create a child contact record. So if you want to build a relationship between a parent account and a child contact, you need to know the ID of the account record. And that ID, if I jump back, is going to be created at the save point. So in an after trigger, you have access to the ID. So if you want to do something in that scenario I talked about, you would have to do that in an after trigger. You could do validation in an after trigger instead of a before trigger, but it's much less efficient. If you look at that order of execution, if you're not happy with the record, it's much more efficient to make the decision at the green blob and send it back than to do it at the purple blob, because then you just waste the server's time doing all that save stuff, but you're going to throw the record away and roll back that save anyway. So more efficient to do it in the before trigger. So the little scenario they have here, what type of trigger would use to implement the following logic? When a new account has been created, automatically post a chatter message with a link to that account record to the associated account. So if you're going to do something like that, the link to the account record, you need to know the ID of the account record. You could only really do this on an insert in an after trigger. I hope that makes sense. Let's see, it might be time for a break. What do you think? It's been about an hour since the last one, and we've got until 2 o'clock to do. So if we take a break here, maybe not an unreasonable time, we'll talk more about triggers. So let's take a 10-minute break, team, and then we'll carry on chatting about triggers when we come back from that. So I'm going to set my little counter again, and we'll take a quick break of 10 minutes. Let me find my stopwatch. I'm going to go on mute. I'm going to leave everything running, and I will resume again when this countdown has finished. So let me just get the big old clock going. Countdown, 10 minutes. Set it, start it. So guys, I will be back and talk to you guys in just under 10 minutes time. Okay, talk to you then.
What the teams will do is they'll create this this yesterday. If you weren't able to attend, I recommend just maybe the first 20 minutes or so of yesterday's session. We do have a recording available. And so it'll, in the first part of that session,
Okay. Back from break. Let me just stop the dreaded countdown here before this alarm goes off, because it's very annoying. Clear that, get it out of the way. Open my org. So, hope you're all still there. Looks like you all are. Welcome back. We will continue our discussion on triggers. Let me just make sure my mic is actually working. Yep, I think it is. So let's go for it, guys. So what does a trigger look like? Well, it looks like this. We use the trigger keyword. You give it some sort of name. Usually a naming convention when you create these things is a good idea. You create a trigger on one S object at a time. And then you've got whatever DML events that you want this thing to react to. And you can put one or all of these in here as you see fit. It's a bit of Salesforce arithmetic going on in here. We have before and after triggers, 2 of those. And then we have the 4 DML events. So insert, update, delete, and then undelete. In this case, 2 times 4 actually equals 7. There are 7 possible DML events because you can have a before and after insert, a before and after update, a before and after delete, but there's only an after undelete. There's no concept of before and delete. And then of course the fun bit goes into the trigger block between the curly braces here. We give you these, in the kindness of our heart here at Salesforce, we give you these trigger context variables to help you figure out and build logic inside those trigger blocks. So I'm just going to talk briefly about these guys as we go through, so you're comfortable. There's a relative new one called operation type, which has just appeared a few releases ago. First of all, these booleans, trigger.isInsert, trigger.isBefore. These are used, and I'm going to be jumping forward between the slides here, so I'm sorry about all the jumping around. These are used to sort of structure your trigger block. You may have written a trigger that will react to different DML events like we have here, before insert, before update, and after update. And maybe you want to run slightly different code depending on the nature of the DML event. So you can use these booleans, trigger.isBefore, trigger.insert and update, and there's all the other ones as well, to figure out what is the nature of this event. So for example, if it's a before trigger, trigger.isBefore is going to be true, otherwise it will be false. If it's an insert trigger, then trigger.isInsert is true, otherwise it's false. So you can get the idea. That's one way of doing it. So a relatively new way of doing it is not to use those booleans, is to use operation type. So what this guy does, it returns an enum, a system.trigger operation enumerated value, and that will let you identify the nature of the DML operation. So I'm going to jump forward a few slides, a bit more about this. Something like this. And often this is, worked with a switch statement. So in your trigger block, you have a switch statement on trigger.operation type. And again, these are the enumerated values. You can use this to figure out, what's the nature of the DML events. Sometimes this is a sort of cleaner structure than have a whole load of, nested if blocks. Your choice. No right way or wrong way of doing it. Just, do what makes sense to you. Then, jumping back, we've got these, well, actually, before I talk to those, let me just talk briefly about this one here, because I don't have a slide that is executed. So it seems a little redundant. This is just a Boolean that returns true if your code is being run from a trigger. Otherwise, it returns false. So it's kind of, in a trigger block, it's sort of redundant. But if you think about it, probably in that trigger block, you will be calling methods in classes. And maybe in those methods, you need to know, am I being called from a trigger or am I not? So you can use trigger.is executing in those methods to identify it, which is what the case is. Let's just talk about these other guys, trigger.new and trigger.old and the corresponding new map and old map. So what these are collections. So trigger.new and old, they're lists. New map and old map are maps. And the new stuff is a list of the new data. So if you are inserting a new record, trigger.new will contain a list of the new records to be inserted. Even if there's only one, if you've just gone through the screen and you've typed in a value and you press save to create a new record, trigger.new is always going to be a list. It will just have one element in the list. Trigger.new map is the same data, but in a map format. Key value pair, where the key is the record ID and the value is the record itself. Trigger.old is the existing data. So if you're updating a record, trigger.new is going to contain the new stuff you just typed into the screen. Trigger.old is going to contain the old stuff, the stuff that's currently in the database before the update is applied. And old maps, again, same data as in trigger.old, but in a map format. Again, key value pair, where the key is the ID and the value is the record itself. So all of those things together mean you can pretty much identify what the hell is going on inside these trigger blocks. So you tend to see a pattern like this. You will inevitably be iterating through. You usually want to do something to the records that are being inserted, updated, deleted, or undeleted, or whatever. So they're always going to come back to you in a collection. So inevitably you find yourself often iterating through one of those collections. So here we've got trigger.new on line 4 in this code snippet. Now let's say you are interested in doing an update. In this case it's an after update. But you're only really interested in the updates to a single specific field that belongs to that record. The problem we have is we can't tell the trigger, I only want you to run if somebody updates a field called start date on this particular record. All we can say to the trigger is, I want you to run whenever somebody updates the record. And that update can be completely innocuous. It could be something you don't care about. So what you have to do in your trigger block is basically filter it and really identify, is this an update I actually do care about? So the way that typically you would do that is you would iterate through on line 4 the records that are being, let's say, updated. That will cd.startDate is going to give you what's the new value of, let's say, start date. And you want to know, has that changed? It changes to that field we are, in this example, interested in. So the pattern you usually see is you need to identify what's the value of start date on the old record. So normally what you'll do is this, you'll use trigger.oldMap, get me the value associated with the record ID. You know the record ID because you have it in here. So you use that as the key. That will retrieve the old record, and then .start date is going to give you the value of that field for the old record. And you usually use the map to do this because it lets you get at the, for sure means you're comparing the right new record with the right old record. You're comparing apples with apples because you're using the record ID for that comparison. And then if they're not the same, you know something's changed that you're interested in, and you can go ahead and do whatever logic you need to do. Then not to use the list in this example, or we don't use trigger.old. You potentially could do because it's just indexed, but there's no guarantee that trigger.new and trigger.old is going to be in the same order. So usually when you're comparing new to old, you use the old map to reference the old data. The other thing to be aware of is this magic number 200 rears its ugly head again. Triggers are always implicitly batched. The maximum value of those collections, trigger.new and all of them, is 200 records. They will never be bigger than 200 records. It just means that if you throw, excuse me, if you throw more than 200 records into a single transaction, so let's say via, I don't know, by Apex code, like you run it execute anonymous and you are updating 300 records in one go, it just means the trigger will be called twice. First time with the first 200 records, and then it'll basically go through in batches of 200 until it exhausts the collection. So in that example at the top, if it was 300 records, the trigger would be called twice. Trigger.new would contain the first 200 records, we deal with that, and then we'll go back, the trigger will be called again with the next 100 records. So bear in mind that batching mechanism is always available, and it's always there for the way triggers are going to work. If you are throwing records using not an update or an insert, but an upsert, if you're using upsert DML command, again, the trigger will be called twice because it will split out the inserts from the updates. So you find two invocations to the trigger, one based upon the updates and one based upon the, upon the inserts. And then finally, if you are doing something like super validation and you want to tell the user you're not happy, in a custom validation rule, you just return true and you put some sort of error message in there. In Apex code, you use the add error method. This only works when you're working through trigger records here. Use add error, and then you put some sort of string in there that will be sent back to the user. So it stops this record in its tracks. It doesn't go any further, and whatever message you put in here, and again, you wouldn't normally hard code it as a string. You'll probably use a custom object. That would be sent back to the user if they're looking at it from the screen. If you do like we've done here, object.addError, so that's basically the record, then the error message is put back at the top of the screen. If you actually, as the note at the bottom here says, object.field, like cd.start_date_c.addError, then the error message, if you're coming from the UI, is going to be positioned next to the offending field. So it's the same sort of thing that you will be used to doing in a custom validation rule. Now, the custom validation rules let you want the error message, top of the page, next to the field, same kind of deal in here. Hope that makes sense. Now, one final point in here, and again, I put this in here because it's not an uncommon thing to have some sort of certification test on this. Where the hell are these context variables available, and where are they writable? The life of me, I can never really remember this stuff, so I try to have to sort of put it into this table to sort of help me. So this tells me that if I'm doing an insert, there's no old stuff at all. So trigger.old and trigger.old map, always null. In a before insert, only trigger.new is available. There's no trigger.new map because there's no ID yet. It's before the save. But it's writable, so you can mess around with the contents of those records. In an after insert, both new and now new map are available to you, but it's all read-only. Everything in an after trigger is always read-only. If you're doing an update, you've got the full set, because there is old data as well as new data. And new map are writable. In the before, always read-only in the after. If you're doing a delete, there's no new stuff. So trigger.new and trigger.new map are null, and you use the old map. Again, everything is read-only in this example. And on undelete, there is no before undelete. And it's in the after undelete, it's trigger.new that would be populated. Trigger.old and old map is set to null. So I hope this helps a little bit. These are slides, perhaps discussed in slightly more detail. I also did a Trailhead live session on this a couple of weeks ago. So you'll find all this stuff where you can replay it if you really, aren't tired of the sound of my voice by now. On Trailhead Live, there's a session in there I do on triggers where I included this slide. So you can replay it there if you need that kind of stuff. All right, let's talk now about the save order of execution. This journey that your data is going to make from, let's say, screen to database. We talked about it a little bit just now. This concept of this two-stage operation where we have the save and the commit, and we have before and have after triggers. We're just going to go into a little bit more detail. Bear in mind, this is also applicable to delete and undelete operations. It just tends to be a bit simpler there. I tend to talk about it from the aspect of inserts and updates because it's a bit more interesting if we talk about it from those DML operations. So here's the deal. Let's say Simon comes along. I'm on the screen here through the UI, through Lightning Experience, and I enter some new data. I'm going to create a new record, or maybe I'm updating an existing one. So what will happen is we enter this thing called the order of execution. And the first step is we load the original records from the database if we're doing an update. So this is where trigger.old will get populated here. If it's an insert, we initialize trigger.old to null at this point. Then we will load the field values from the request. So this is where trigger.new will get populated. And if and only if the request is coming from the UI, we will perform system validation. System validation means required fields, either in the database or in the UI, or field formats. You know, you said it's an email field, it's got to have email-looking data in there with an @ sign, for example. So it checks all that stuff if you're coming from the UI. But if you are not coming from the UI, it would not do system validation at this point. So if you come from data loader, or from the API, or from Apex, or something like that. Then it's going to run before update flows. This is a new feature that was added in, I think, Spring 20. So you can create a flow, an auto-launched flow, and it will run here, and then it will run any before triggers. You can have more than one before trigger. As a best practice, try and keep it to just one. Otherwise, if there's more than one, you can't control things like the order in which they are executed. Then it will run most system validation steps again, and this is where it runs your custom validation rules. Most system validation means it's not going to run any UI specific validation. So if you've made a field required in the UI, it will be tested at that second step, but not again here. Then if you're using them, duplicate rule checking will be done here. Again, only if you're using duplicate rules. And then it will hit the save. Okay? So that's what happens in that part of the order of execution. Consider this scenario. Let's say a user like me is coming from the UI and I hit save on a course delivery record. So we start coming around the blobs here on the right-hand side. We pass system validation here, that second step. We have a before trigger that runs. And then we get to this fourth blob and we get a system validation error. So what is the likely culprit there? What's probably happened? Give you a moment to think about this, because obviously this is a bit rhetorical. Well, the likely thing is, remember, in a before trigger, you can mess with the data. So probably some enthusiastic developer has done something like blot out a required field or put an invalid, text into an email field or something like that. So they've done something goofy, and that will be detected in that validation that we do after the before trigger executes. All right, let me do the save, and then we enter the stuff after the save. So we'll run any after triggers. Then we will evaluate any workflow rules. Now, I don't know if you guys can remember what a workflow rule does, because you should do. There are 4 things. It can send an email, it can post an outbound SOAP message, it can create a task, or it can update a field. Now, if a workflow updates a field on this record and the value of that field actually changes, because it has to change, then you might get this kind of thing going on. You get this little triangle jobby. You get any before triggers, or before update triggers, of course, will run again. You'll get system validation again, no custom validation though. You'll get the save again, and you only get any after update triggers again. Okay? And there may be multiple workflow rules running there. You won't go around that route multiple times for multiple workflow rules. It kind of executes all of them here, and then it'll do that. But this thing may make changes, that Apex code, which calls other workflows to run. So, which wouldn't normally would not normally be evaluated depending on the results of your initial insert. So you may actually end up going around that loop more than once. There is a maximum of 5 further times around there. All right, then we'll do the same thing with processes or flows. Now, you can do a hell of a lot more with a process/flow, and I'm not sure I can remember everything now because they keep adding to the list. But one of the things it can do is update a field. updates a field on this record and actually that value in the field changes, then we're going to get this kind of deal going on again. So before update triggers, again, system validation, again, and actually also it will run custom validation at this point. Save the record again after update triggers again. And, you know, processes can be recursive, so you may go around that route multiple times. Again, to the maximum of 5 additional times. Then we will do any roll-up summary calculations or cross-subject workflow on parents and ancestors and grandparents as well. So if you have a roll-up summary, it'll reach up to the parent and save it. It might go up further than that necessarily. That happens there. Then we will do any sharing calculation we need to do. I'm not going to discuss the way that works. We just don't have time to get into detail about what's going on in here, but basically that will update the sharing tables. Then finally, we will commit. So we get to the commit point. The record is visible to the outside world, and we'll do post-commit logic. So and that's things like, you know, sending an email or outbound messages or that stuff like that. Now, if you did in that example there reach up to a parent and save the record through a roll-up summary field, you're going to get another order of execution on the parent. So not just one of these rings, but maybe more than one of these rings if that recalculation occurs. So you're going to get this whole thing going off on the parent, the master record, if you like. The only difference is you won't get that commit and that post-commit phase. There's only ever one commit and post-commit. I don't know if you guys are familiar with Lord of the Rings, the Lord of the Rings movies, wherever you are. The one ring to rule them all, and in the darkness bind them. This initial order of execution, it's the one ring, because it controls when the commit and post-commit happens. So whatever, any sort of DML operation anywhere with an order of execution will throw another order of execution, but it will not do a commit and post-commit. It's all done in one place for the whole lot, right at the end of the one ring here. Which is kind of what that's. Now there's a comment here about things like trigger recursion, which we can guard against. I'm not gonna get into that here. Now we did simplify that a little bit. We left out things like assignment and auto response rules and escalation entitlement rules. They are part of this. We took them out because they only apply to a couple of specific custom objects, cases and leads, cases notably here. So if you're working with a case S object, there's additional stuff that potentially can go on here at these points in this order of execution. There's actually 21 steps now. We've simplified this to about 12 or 13 here. There's actually about 21 steps. You can read about it in the Apex Developer Guide. The post-commit logic, it's things like sending emails, outbound messages, and also any asynchronous Apex will be queued for execution in that post-commit phase. There may be some questions about asynchronous Apex insert. My colleague who took this a couple of months ago did mention he saw some stuff about @future in there. So if we get some time, I don't know whether we'll have time in the, because we've got about an hour and 40 minutes left here. We might have a chat about it, but if not, I'll remind you at the end to go look up the use of things like @future methods or queuable or batch Apex. Just read up a little bit about it. You did remind me there was some stuff about, we didn't really expect that, but they've updated the cert. And I believe there was some talk about the use of @future methods. @future methods, if you designated a class as a future method with a sort of an @future annotation, it's queued for execution here. It's not executed as and when it's called. It's actually queued for execution in this post-commit phase, and it runs at some point in the future in its own transaction. So it gets its own set of governor limits. Right, let me just have a quick sip of water. Let my voice lasts. I put a brief couple of slides in here about platform events, because I think they're explicitly mentioned in the exam guide. And my buddy did tell me he saw some stuff about this in here. I don't know exactly the detail. So platform events, they ran a couple of years ago, and they're built around this publish, subscribe model. So Salesforce has this event bus that we can use, and we can publish events onto this event bus, and we can subscribe to the event bus and retrieve information about events that we are interested in. Platform events are something that we construct ourselves. We design them. They kind of look a little bit like a custom object in that we can add our own fields. But they have, instead of __C in their API name, they have __E in their API name. And if you design one, they can be published either internally by Apex, or by maybe processes or flows, or externally. So you can use these things for external applications to publish these events, and then we can subscribe to them either externally or internally, again using provide processes or flows or via Apex triggers. So they're a very cool mechanism for passing data around between entities in our Salesforce world, and those entities could be on the platform or they could be off the platform. When you design one of these events, they can also be designed to sort of publish what they call immediately in the order of execution or after the commit. So if I'm just going to jump back a little bit here, after the commit means I would add it to this post-commit bit. So if something in some code or a process in the ring here has published the platform event and it's said, and the event design says after commit, well, it will be published after the commit. If we don't get to the commit and something bad happens, the whole thing gets rolled back. The commit, include not all our DML, but also that event would never be published. If you say immediate, it will happen at that point in time. So, for example, an after trigger here, we publish an immediate event. It's going to be published then, no matter what happens subsequently, even if the transaction dies and goes to hell. So I put some notes in here about sort of just publishing and subscribing from Apex. So to publish it, you might do something like this. You might create an instance of the platform event object. So notice here you see the __E. You can't treat this like a custom object, but it isn't. It's a platform event. So you might create an instance of it. I've actually created an empty list of these things. Here's my instance, rather, of the actual event. I'm setting any fields. So again, exactly like you would do with a custom object, but you don't do an insert here. You do event bus.publish, and this is the thing that puts it on that event bus. So this is the thing that actually sends it out into the outside world. Okay, so event.bus.publish to kind of publish the event. On the receiving end, you might do something like this. You could actually you can create Apex triggers that will react to the arrival of a particular event. So I called it notification _E here. Okay. This will only be after insert. That's the only supported operation here. And again, you would treat that just like you would a custom object. So trigger.new will be a collection of platform event objects. So you can iterate through that one at a time and then do what you need to do in here. So very, very brief. If you're interested in more, there's reasonably good trails on Trailhead about platform events. Just make sure, I think, when you do the certs, that you have some knowledge. This might be good enough, what I've done here, I'm not sure. But there was definitely something about platform events in the test that my buddy told me about a couple of months ago. And if there is, it should be a fairly straightforward question. So this might be an easy win if you just know a little bit about platform events. So I hope that will help when you get there. Okay, let's switch now. Let me have a quick drink of water. To the UI. This is going to still include questions about Visualforce. I know many of you will probably not be working Classic. You may be working entirely in Lightning Experience or Communities. And you'll be asking the question, well, why the hell do we have Visualforce in here? It's a good question. Honestly, the reason is it's still a huge part of the Salesforce ecosystem. There are many customers who are still on Classic or still in the process of moving from Classic to Lightning Experience. Either they have a large investment in Visualforce, there's millions of Visualforce pages still in production, and often they will actually, and they can reuse those pages in Lightning. So it's still appropriate from that perspective. And it's still part of the certification, not a huge part now, because I think they probably tweaked it a bit and reduced it a little bit, but I'm sure it's still there. So some sense of, working with Visualforce is still going to be, required. Not huge detail, but a feeling for it. And it's quite a big chunk of the test. 25% is about the UI, although not all of that is going to be Visualforce, of course. So we've got some stuff on Visualforce here. The Lightning Component Framework, they used to be very, very brief. I think they will have expanded this a bit now in the certification. So I have tried to do that in these slides here. I'm going to try and talk about both the Aura model, which has been around for a long time, and the more recent Lightning Web Component programming model. I'll try and touch briefly on really both of those. Including what these components actually look like. They're not going to go into massive detail in the Platform Developer 1, but I think you need to know a little bit. Again, it should be an easy question. If they're going to ask stuff about this, it's not going to be super detailed. If you've got some knowledge, that's probably all you're going to need. We'll try and touch briefly about security. I'm not sure I've got too much about here in that. And sort of scenario questions, always a favourite of the examiners. Around, when do you use Lightning Components or Visual Flow or Visualforce, that kind of thing. And the event model in Lightning, I haven't really included this at all, just because of time. So how we work with Lightning Component events and application events for Aura or custom events for Lightning Web Components. So I don't think I have much time to put anything about that in there. I'll direct you to some Trailhead material for that if we get a chance. Or if we get time, I will talk about it. We're about an hour and a half to go. What else? User interface requirements, interactions between Apex. Yep, we still need Apex in this game. So let's give this a shot and see how we go here. I am going to start off with Visualforce. It's difficult to be succinct when you talk about Visualforce because they are going to ask you a few questions, and they'll probably be stinkers if they do this sort of thing. And I particularly want to do it because I know a lot of you, if you've got Salesforce, you're already listening to it, you're not going to know much about Visualforce. And I want to try and cover as much as I can to give you a fighting chance to hit these questions. So the way it works is there's two bits to a Visualforce page. There's the visual aspect, the page. Here's a brief example, which is built using this Visualforce markup language. And then there's something called the controller. If you remember model view controller, so model, database, view, Visualforce page, controller, lump of software that connects the view to the model, the page to the database. Visualforce has two. It has standard controllers, so we give you these. You don't see the code for these. You can just use them. They are there for you to use. Or if they don't do what you want, you can either extend them or completely replace them with custom controllers, and this will all be written in Apex. So I want to try and show you an example using the standard controller, just to give you guys a feel for it. Standard controllers need, if you're going to work with a record, they need an ID. So when you reference a Visualforce page, the URL is going to be your pod, whatever it is, /apex/page name. And if you're using a standard controller, then it will look on that URL for the ID of the record that it's going to work with. So I'm just going to try and give you a brief, hopefully brief, demo. Oh, my voice is starting to go. So let's go here. And I'll tell you what I'm going to do. I'm just going to open a couple of tabs in my org. Oops, let's get my VS Code out of the way. Now I'm just going to try and write on the fly a simple Visualforce page to give you guys a bit of a feel for this. Now I have done a sneaky thing here. You can author Visualforce pages in Developer Console. The IDEs like Microsoft VS Code, you've seen that pop up on the screen a few times. You can do it there, all the IDEs actually, not just the ones that we supplied. But there's another sneaky thing you can do, which I have enabled in my org. If I go into my little avatar here, and I go to the settings for my user identity, and I go into advanced user details, I've done something in here called, I've enabled what's called development mode. That little checkbox there. So what that does, it enables the Visualforce inline editor. It sounds rather grand. So let me just show you what that looks like. I just need a tab in my org here. And I'm going to put in the URL of a Visualforce page, one that does not exist. So I do know it will start /apex, and then let's call it, I don't know, demo page or something like that. So I get an error. It says, hey, that page doesn't exist, which it doesn't. But because I have that inline editor enabled, I have this link. So this will let me create a Visualforce page for me on the fly, which is what it's done. Doesn't it very interesting? Let me zoom a little bit here. So it's congratulations, this is your new page. But down here, I've got this little bar appears at the bottom, and if I hit the little up arrow and just drag that up a little bit, this is the source code for my Visualforce page. So this is my page at the top. This is the source code for that page. And this, if you're learning Visualforce or if you're just playing around with it, this is pretty cool because you get instant gratification. I can make changes to this page. For example, I can take out all the content and I can save it, and I get instant gratification for my changes here. All Visualforce pages start like that, and they end like that. And what goes in the middle is entirely up to you, up to me actually. So for example, I could do, you know, the traditional hello world kind of thing. Let's spell it like I suppose would be good. Let's close the bold tag here. And I can save it. And there you go, hello world out there. Not very interesting. I could start talking to the standard controller. The standard controller, this lump of software, is connecting my page to my database. So you talk to the standard controllers using this expression syntax like that. And inside here, I can ask it, there's a global variable called $user, and I can say first name, that's a field for the user record, and I can save that. Hello Simon is appearing on the screen here. Okay? So that's me talking to the controller to get information about the currently logged on user. So that's good, I guess, but you would normally want to do something a bit more interesting than that. Visualforce has this whole library of built-in tags. Component reference here will open a tab and it will show you a big list of markup. These are the things that I can play with on a Visualforce page. Some of them are really interesting. For example, Apex Map. That's Google Maps. I can throw Google Maps in here. And the documentation is pretty good on how to do this. So I'm going to not say hello Simon. Let's work with, I don't know, let's work with an actual object, S object and a record. So what I'm going to do is I'm going to tell this thing to use, I'm going to tell this page's standard controller to work with a specific S object, you've got to choose one and only one. I'm going to use a count, because everybody can play with a count. Okay. Now, if I just do that and I hit save, you know, apart from the fact that I've removed the text here, nothing happens. Okay. Now, that standard controller, because I've told it to use an S object, it wants to find an ID, so I've got to give it one. So I'm going to just go find an account record. Let's pick on Acme Inc., as is traditional. Let me grab the ID from the URL here, jump back to my page, and on the end it's just question mark ID equals that. Okay? Nothing happens. A whole lot of nothing happening here. But now my standard controller is happy. It's been told what S object to work with. It's been told what record to work with. Now I can start to ask it questions. So for example, if I wanted to know the name of the account, I can use my expression syntax, and I can just say account.name, and let's see what happens. Now you see Acme Inc. has appeared. So now I'm actually getting the controller to go get me information from the database, from the model. Let's get rid of that. And let's build something a bit more interesting. I'm going to use some of those numerous tabs that appeared. I'm just going to try and build this, you know, relatively quickly. I want to have a tabbed interface. So I'm going to use, and there's some IntelliSense in here, I'm going to use a Visualforce tag called Apex Tab Panel. And in here, I'm going to have two tabs. Oops. Tab like that. Times, there we go. I want to see that guy. That's the guy. So let's make it pretty, and I want two of these things. So I'm just going to do a little bit of copy and pasting action here. Save it. Let's see what it looks like. Not very interesting, but you can start to see the page building up here. Now my first tab, I'm going to give it a label. And I'll call it details. And my second guy, I'm going to give it a label. I'm going to call that lists. Save that. You start to see this forming up here. Okay. Now my first one here in this tab, I want to show the standard detail view for an account record. So there is a coarse-grained, what they call a coarse-grained Apex Visualforce tag called Apex Detail, which will show me that. So if I save that, now things look a bit more interesting. Okay, it's actually done all that for me, just that one liner. It's the classic UI though. Hey, I'm in Lightning, so okay, I can fix that. I can tell the page, would you awfully mind using the Lightning style sheet? Style this to look like Lightning. Now that looks a bit more normal if you're using Lightning Experience. Okay, so it's using exactly the same styling as it does for Lightning. Nothing happening here yet though. It's empty. So let's fix that. Let's put my related lists in there. So there's a tag called related list. You have to give it the name of the list. And you know, this is reaching down from the parent account record to child contact. It wants the collection of contact records. So again, this is another use of the plural form. So I save that there, and I go look here. There's my related list of contacts. Okay. So I just want to do that real quick to give you guys, if you've not seen Visualforce before, a sense of, you know, what the hell is going on here. Visualforce is actually very easy to work with. I mean, a little bit of a learning curve, of course, but it's very quick to get interesting results like that. So I hope that made some sort of sense to you guys. Now, where does it fit in this whole model view controller thing? So out of the box, we have a standard UI, page layouts, if you're classic or, you know, like the experience pages. We have the model, standard and custom objects, and then we have a lump of software that connects the two. So what I just did is I took over the view aspect of that with my own page, but the mod bit was the same, and I used the out-of-the-box standard controller, okay, in that example. I also accessed my page by typing /apex/page name, which of course you would never do in a real world. So you would surface what we call make Visualforce pages available, surface them in all sorts of different ways. You know, there's loads of them. You can have buttons and links. You can override actions. You can create its own tab. You can actually embed Visualforce in Lightning. You know, if you in Page Layout Editor in Lightning, you can actually embed Visualforce pages in there. So you can have a view in Lightning Experience if you're looking at a record. Half of it could be the normal stuff. Then you can have a Visualforce page in there. And if you've styled your Visualforce page to look like Lightning, the user's hard put to tell the difference. And there are some other options as well, things like mobile cards and custom actions and stuff like that. So there's loads of them out there. Now, when do you need to think about, you know, playing around with the other aspect of Visualforce, which is the controller piece, if you like? So remember, we worked with the controller just now. I showed you the expression syntax. You use this object.fieldName kind of deal to do this. And there's all sorts of tags that will work with that. Or you've got global variables, you know, to play with. That's great. It will work with collections. So we can do relationship traversal in Visualforce. And the same rules apply here as it does for SOCL. Same syntax, same rules. So if you're traversing from child to parent, it's 5 levels up and no more. If you're going from parent down to child, like we have at the bottom here, it's 1 level down and no more. So same rules apply as we used to with SOCL in here. So that's important to know. You can also, these controllers also have actions available, you know, things like, do you want to save a record or edit or delete? And a number of different Visualforce markup, you know, tags will support those actions. Again, I'm not going to go into huge detail here. Now, one reason, you know, and this is a sort of thing they tend to like to ask you in these damn tests, is, okay, when do you need to use, or when can't you use, perhaps is the right word because I put it on the slide, when you can't use a standard controller. So let's say you might be asked a question, you know, I want you to create a Visualforce page, and I want you to use the standard controller, and I want you to tell that standard controller to work on an account record, like I just did. Okay? Now, if you only need to retrieve information about the child contact records, that's fine. You can do that, because you can reach 1 level down, same as you could with a SOCL query if you were starting on the account object. But if the business requirement is to show an account record and these related held records here, then the standard controller can't do that. You know, it has to obey that 5 up, 1 down type of rule. So this would be a case where you would need to replace the standard controller, or you would need to extend the standard controller to sort of bolt on some additional functionality. You might also need to do it, you know, if you want to do things like control the navigation. You know, if you're using a standard controller, you know, the navigation is very restricted. It does what it does. If you want to just sort of jump to some sort of random page in your Lightning experience, you need to control that navigation explicitly. So that might be another reason to, use your own code or change the security behavior. The other thing is standard controllers, standard behavior. You know, they obey all the security rules. They're good like that. You know, if you want though to get around those security rules for whatever good reason, then again, remember, you're going to use your own custom Apex code. It's going to be system mode. You know, you don't have to obey the security model. There's a good reason for doing that. If you do write a page that's going to use the custom controller, you saw me just now use standard controller equals account. If I'd wanted to extend that, I wanted to bolt my own Apex class to that. Say that standard controller did everything I need. The only thing is, when I save that record, I want to navigate somewhere else. Well, I could then add an extension using the extensions attribute, and that would just be the name of an Apex class. You can actually have multiple ones in here, but usually just one. If I said that, that standard controller, it does nothing of interest to me, I need to do everything myself, you just use the controller attribute. And again, that's just the name of an Apex class in there. You can extend that too, but that would be relatively unusual, I think, to want to do that. Well, one thing they might say is, let's say in this top example, the standard controller has an action called save. You want to press save, but you want it to go somewhere explicit. If you have a save method in these Apex classes, it'll look in the extensions first. So if you press save, it would look in, and if you've got more than one extension, it starts from left to right. So it would look in this first class here, is there a method called save in there? If there is, it'll run it. If there isn't, it will look in the next one. If there is, it will run it. If there isn't, it's going to use the save, action from the standard controller. So the other question they like to ask is, okay, the standard controller is not going to cut the mustard. You've got to add your own custom functionality. What should you do? Should you use a controller extension, extend the standard controller, or completely replace it with your own custom code? So again, a difficult question sometimes, because sometimes it could be either. Frankly, either would work. Typically, you want to use functionality already existing in the standard controller. So maybe the standard controller has got 90% of what you need. You just need to add a bit more. So it kind of makes sense. The minimum amount of work would be to use an extension in that case. Or maybe you have to use the standard controller. If you are embedding your Visualforce page into a page layout, you have to use the standard controller to do that. If you want your Visualforce page to be behind a button in the page layout, you must use the standard controller. So if you want to bolt your own functionality onto that, you've got to use an extension to do that. There's only one time where you have to use a custom controller, and that's if you want to have a controller for custom Visualforce components. So Visualforce actually has pages and components as well. I'm not going to talk about Visualforce components here. I don't think they're going to be part of Platform Developer 1. I'd hate to be called wrong there, but I'm honestly not sure. Maybe a quick read up about that, just to be on the safe side. I've not included it in the materials here. Now, if you do write your own custom controller class, what's it going to look like? Well, if you think about it, the job of the controller is to get information from the database to the page and to set information from the page to the database. So you will have in there what they call getters and setters. And these can either be written using method syntax, like get this or set this, or property syntax, using get, and this is just a getter in here, or get set in the curly braces here. So they both do very, very similar things. If you write a lot of Apex Visualforce controllers, you tend to pick one way and stick with it. And this actually confuses a lot of people, the fact that we have two ways of writing these getters and setters, using methods or properties. The other thing a controller might have is a action method. You want to click a button, go do something, navigate somewhere. So you'll have a method in here, and usually they will return something called a page reference, which is a Visualforce navigation object. If it's a controller extension, needs a constructor. Okay? If it's a custom controller, doesn't need one. If it's a controller extension, does need one. Okay? This constructor takes in the reference to the standard controller object, and it uses that to identify the record that that standard controller is working on. Okay. So again, I don't want to spend too long on Visualforce. I'm unsure of the amount of Visualforce that's actually going to be in the cert. I've got a couple of scenario questions here, which is the sort of thing they might try and run past you, hopefully a bit more specific. This is just taken from our in our training classes. So let's say, there's a scenario that says, I want you to create a page that will allow me on the page to enter data for account, contact, and opportunity records. Press a button, create all three, and build the relationships from contact and opportunity up to that account record. So, they might ask you, well, now you can't do that out of the box just with a single standard controller for sure. So you would need some custom code, custom controller or controller extension. Probably custom controller might be able to do it with a controller extension. So that would be maybe both here, but probably cleaner to do it with a custom controller. But actually, sometimes there's no right or wrong answer. Hopefully, in an exam situation, there would be a clear-cut, decision here. A page with custom functionality that can be launched using a button. And now, if you're going to launch it with a button, you must use standard controller. So the only option to apply your own custom code would be a controller extension in this example. Some sort of multi-page wizard, which guides a user through the process of designing a sales plan or something like that. And you customer, so multiple Visualforce pages controlling the navigation between them, almost certainly a custom controller in that example. So you have complete control over navigation. So the standard controller wouldn't really lend anything to that scenario. And finally, a page that on saving a new certification record automatically redirects you to a page where they can do something else. So what they're kind of saying here, it looks like the standard controller does everything you need, except that one sort of last navigation bit, in which case a controller extension would probably be the way to go there. Okay, so look out for these sort of scenario type questions. If you haven't touched Visualforce at all and you don't really want to, they're going to be tricky. You're going to basically have to take your best shot, because it is a bit of a learning curve to get, as you've probably get a sense of it, to go through Visualforce. It's not a long one, but it's a pretty steep one. The other thing the examiners love to ask you about, it really gets them hot, is Visualforce list, standard list, and custom list controllers. Do want to try and show you an example of this to give you a sense of what I'm on about here. So we'll talk about what they mean by the standard list controller. So that example I just showed you, I was using the standard controller for an account, but it was working on a single record. It needed the ID. If I give it this weird attribute name in the page here called record set var, that enables something called the standard list controller. And it will work with a collection of records. And that collection is driven by list views. Sounds a bit weird. Let me try and show you what I mean here. So I need to go to my org. And I need to search for my Visualforce pages, so I need to find the one I'm interested in. I think I called this one list accounts. Yeah, let's use this guy here. Now I've found very, very small amount of code, so I'm just going to go and preview this thing. So here's the code, 8 lines. Here's what you're seeing on the screen. Okay. Now I'm just going to go to my account tab, and I'm going to choose a list view. This one I think only brings back 12 account records, and I'm just going to refresh this. And you can see those same 12 account records in here. So the way this works is in the code here, you have standard controller for account, you've got this record set var thing, and that's just a variable name. That will be populated with the last active list view for the account object, which is that lot there. Okay? And then there's just some code here to stick them into a table. If I go back and I change that list view to all accounts, there's probably 100 or so of these, and I go back and I refresh my page. Oh, bugger. I refresh my page here. then you can see I actually have the first 20 records by default of that collection. Okay, so this is the standard list controller. Now that in itself is not massively useful, I have to tell you, but the full power of these standard list controllers is not shown in that example. Let me just find another Visualforce page, at least try to. I think it's called account display. It's this one. Right, so this is a big chunk of code here, but there's no apex involved. If I preview this, then now you get a sense of the full power of this standard list controller. I can choose the list view. Okay? Service vendor accounts. There we go. You can see all 12 records in here, and it's telling me 1 through 12. Basically, this has a paging capability. If I choose all accounts, it's showing me the first 20 records. Well, there's 129 in total, and I can page through this one at a time. Okay? I can reset the page size to anything up to 2,000 records. So I can go to 5, for example, and now I can page through that result set, 5 records at a time. It took quite a while to go through that. But that's the standard list controller. It's a chunky old set of Visualforce markup, which is this stuff here. So you can see there's quite a lot of code in here, but there's no apex. It's all done in the markup here, using the standard controller. The only drawback, if you like, is that the result of the collection must use a list view. So that list view must exist, and I must have access to it. So that's the thing that kind of holds you back in this. But if that list view does exist, then this is a very cool and actually quite straightforward way to work with collections of data. And it's actually much easier to do it with Visualforce than it is with Lightning, incidentally, in here when you're paging through this stuff. So the standard list controller, they like to ask you about that. Now, because the restriction is that this is driven, that collection is kind of tied to list views, if you don't want to have that restriction, then you use the custom list controller. And this uses an entity in your code called the Apex Pages Standard Set Controller. And this thing you can populate with the results of a query or the results of a search. Basically, you form the collection programmatically. You're not tied to list views, but you still get that same kind of paging capability that you saw with the standard list controller. So if I try to show you an example of this real quick, I need to go back to my list of Visualforce pages. I think it's called Display Contacts, this one. So this, if I preview this is a page that actually does use Apex. You need Apex in this game. But the idea here is I can search for, I'm just using on a contact record. If I'm going to do a find all fields for contact records containing the string training. So when I hit that, that's what it's done. It's actually done a find here. And it's found 190 records. And again, I can page through this very, very easily. So I get the same sort of paging and sexy capability that you do with a standard list controller, but because I'm using a custom one with that standard set controller object, the collection I can form either using a query, or in this particular case, we used a find, a search to do this. The code is quite chunky, as you might expect, I suppose. And there's 2 bits of it. There's the Visualforce page here. So you can see there's some to-dos in here. But you can see it's, there's a fair amount of code. But also, and one of the nice things about this inline editor is if you look here, it's not got a standard controller, it's got controller. So it's using a custom controller. So I can actually jump straight to the Apex code. And this is the Apex code that, lets me see what's going on, behind the scenes. Remember, this is the thing that's connecting page to the database. And that is the object that's making all this happen. Again, I'm not going to go into this in detail. It would be difficult to do in a scenario like this for you guys anyway. If you want to know more, then again, I think there's some probably stuff on Trailhead that will help a little bit about here. But there's a lot of documentation out there about this. Google search will be your friend here, because Visualforce has been around for a long time. So there's loads of information about it. They do like to ask you about these list controllers in the cert. So at least have some sort of sense of what the hell's going on here. Because again, it shouldn't be, too difficult a question, as long as you have just have basic knowledge about, about these list and set controllers. So I hope that helps a little bit for you guys. It's kind of tough if you've never touched Visualforce before, but there is some benefit to learning a little bit about it, really just for the purposes of the certification. Okay. Oh, sorry. Switch tracks a little bit. We have an hour to go. A little bit about Lightning Component Framework. So what we mean by that is it's a UI framework. It's a componentized UI framework that lets us build responsive pages which we can assemble easily from subcomponents, if you like. Those components, most of the action in the Lightning Component Framework happens in your browser. It happens client side. So your components consist of usually HTML, there'll be some styling possibly, and usually quite a lot of JavaScript, the devil's language. Often, not always, they would need server-side Apex methods to work with data. Not all the time, but often, you also need Apex as part of this deal. Now, here's perhaps where confusion can arise, and I believe they have modified the cert to ask you to certainly talk about the new programming model. So I joined Salesforce in, was it 2015, I think? And at the time, we were pretty much all classic, and we started releasing what we call the Lightning Component Framework later on that year. Prior to that, we still had something called Aura. So the Aura framework was developed, it was an open source framework that was developed by Salesforce exclusively for the mobile platform. And I think we realized if we did a little bit more work, then we could have a generalized, component framework, responsive, that would work on all our UIs. So the Lightning Component Framework was built on top of that original Aura framework. And it was launched, I think really officially launched about 2015 actually. But they started working on it a lot earlier. At that time, the web standards that we needed were pretty immature. So Salesforce, like many other companies, we had to write a lot of our own code in the browser to get the sort of behavior that we wanted. We wanted custom components. We wanted our own event model. We wanted to work with modules. We wanted to work with data. We wanted to worry a bit about security. But none of that, or a lot of it, wasn't available in the web standards that are at the time, so we had to build our own. 5 years later, those standards have evolved quite considerably. So, if we had to start again, then the bit that we, Salesforce, will have to do to get the effect we want is much, much smaller, because the browser and the standards that it supports have evolved dramatically. So 5 years ago, we had to write the green bit. We relied on the orange bit from the browser. Now it's turned around. Okay, the green bit that we need is much, much smaller. In fact, it's very small. It's actually kilobytes in size. And the browser now gives us nearly everything we need. We still have to do some stuff. We have to worry a bit about working with data from Salesforce. We have to worry about things like security. But, a lot of the other stuff we need is part of the browser now. So what we did here is we created this new programming model called Lightning Web Components. So for the last 4 or 5 years, we've had what we just originally called the Lightning Component Framework. And the components that were written for that, we kind of call those components are written using the Aura programming model. Now the Lightning Component Framework supports two programming models, the Aura one and the Lightning Web Component one. Confused? So, what is it? A Lightning Component Framework is a Lightning Component. Actually, I said a Lightning Component Framework there. It should just say Lightning Component. It's a self-contained, reusable piece of the UI. It doesn't matter whether it was written in Aura or a Lightning Web Component. And it can be very, very small, maybe just a single line of text, very tiny, or it could be very large, very big-grained, contain other lots of components, almost to the extent that it's almost in itself a single application. Components can be written in Aura, using the Aura programming model, or the more modern Lightning Web Component programming model. Now, we also have this concept of a Lightning application. So this is a top-level container. It has a URL, and it can contain Lightning components. There are three Lightning applications that we ship out of the box: Lightning Experience, Communities, and the mobile platform. They are all Lightning applications. They are at the top of the pile, and they contain components. They can't contain another Lightning application. We can also create our own custom ones, but right now only using the Aura programming model, although it can call components written with the Lightning Web Components. All of these things are what are called single-page applications. So the way Visualforce works is when you navigate around, between a Visualforce page, you're basically going to the server, rendering the page has been sent to the browser. If you want another page, you have to go back and do the same thing. In the Lightning Component Framework, there is only one page. It gets loaded up front, you stay on that page, and as you manipulate it, as you sort of navigate around within the page, it's all being done with JavaScript in the client, on the page, and we only go back to the server to get and set any specific data that we need. So it relies much more heavily on what's going on in the browser, but of course the network communication is much lighter, much more suited, for example, to mobile, but also works pretty well on the desktop. So Lightning components by themselves, they can't exist, by themselves. Okay? They have to be contained either in another component or ultimately in a top-level Lightning application. So either Experience, Communities, the mobile platform, or maybe your own custom Aura-based Lightning application. Virtually all of the action happens in your browser here. If it does need data, it's going to have to go to the server to get it, and that might involve a call to Apex using methods that carry a special at Aura enabled application, and this is true for both Lightning Web Components or Aura components. Or there is an Apex-less way of doing it, using Lightning Data Services, which again works both for Aura and Lightning Web Component programming model. What does a component look like? It's a bundle of files. Okay. An Aura one has anything up to 8 what they call resources or files in its bundle. The certs has only ever really asked us about the first 4 if they do drill into this at all. They used to do it, I don't know if they still do, so we want to make sure we cover that. The component part, the resource in the bundle, that's got the UI. It's kind of like the equivalent of the Visualforce page. Now that UI, that markup, they may contain buttons, for example. Users, bless their heart, they like to click on stuff, don't they? So if there's a button there, you need to handle the click event on that button. So in Aura, we had a file called a controller. This was JavaScript, and it had functions in there, which basically were event handlers for stuff that was going on in your component. So if your component had a button, you click the button and call this function in my JavaScript controller. Aura components also have the concept of another JavaScript file called the helper, which we use to sort of contain sort of reusable JavaScript functions so that the controller file didn't grow too large. So you might have like 10 event handlers in your controller, and maybe there's sort of bits of JavaScript in there which are common to a number of those different functions. Well, instead of duplicating it, stuff it into the helper file and just call the helper file. So it just keeps things a little bit more succinct and maintainable. And then there was the style file. So you could apply, CSS classes just to that one component. The other ones, you would not be asked about anything to do with those in the old platform developer one set, and I'm sure they wouldn't have done it in the new one either. A Lightning Web Component is also a bundle, but a little bit different. So anything up to 5 files in the bundle for a Lightning Web Component. What we call the HTML file, so this will be the same as the component file for Aura. So this contains the markup, the view, if you like. There's only a single JavaScript file this time. It contains the class file. This is a more modern version of JavaScript. It actually uses classes and properties. It's very much like the way you structure Apex. So we have only the one JavaScript file here. We still have a CSS file that contains styling. We have an SVG file, scalable vector graphic. It's very, very small use of this. It's just used if you want a pretty little icon in Lightning App Builder, if you want to see your component listed in the palette there. So it's not, widely used. And then there's something called a meta file. So this is a metadata API file, but we make a lot of use of that for Lightning Web Component. It holds target information. When you build an Aura or a Lightning Web Component, as the developer, you are responsible for not only what it looks like, what it does, but where it can be used. Okay? For an Aura component, we use the design file, we use the component file using something called interfaces. So the developer can say, I will allow my component to be used in App Builder, or on a record page, or a home page, or something like that, or as a quick action. In Lightning Web Components, we use the meta file to do the same thing. We have what they call target definitions in there, and it's the same kind of thing. I will allow my component to be used as an app page in App Builder, on a record page, or as a Lightning tab, or something like that. So that information is stored in the meta file for a Lightning Web Component. Now, if you compare Visualforce to Lightning, again, they may do stuff like this, I'm not sure. Visualforce page-centric, stateful server. All the action happens on a server for Visualforce. Not much happens in the client. And it was originally, designed for the desktop. It still works really well on the desktop. It sucks on the mobile platform, though. Lightning Component Framework, single-page architecture, one page. Gets loaded into the browser, up front, that's it. All the state is really maintained in the client. So the servers are just there to sort of get and set data. And, originally great design for mobile, but these days pretty much great for everything, including desktop. Some other stuff. This slide here. So again, Visualforce or Lightning, which would you go for? Well, almost always now, of course, it's going to be Visualforce. So it's our long-term strategy. And you're unlikely these days, I think, to have to make a decision like this. It's going to be Lightning, really, almost always, unless you are actually working in Classic. So it's always it's our long-term deal. It's very convenient because it's componentized. It's great for reuse. It's great for assembling pages. Lightning App Builder lets administrators build pages using Lightning components. Although, to be fair now, you can actually throw Visualforce in there as well. Community Builder supports it very nicely. Should be quicker. There's, of course, been a long debate about this because originally, frankly, it wasn't, but these days it's actually pretty good. Difficult to compare apples with apples here, though. It's definitely better for mobile because it's very succinct in its communication between client and server. Difficult to compare the two. I think people were comparing Visualforce pages which did one thing with a Lightning page which did lots of things and wondering why the Lightning page was taking a bit longer. Well, it's actually doing about 10 times more than a Visualforce page, but it's always been a bit of a difficult to compare the two. But certainly on things like manipulating a page, because it's all client-side using JavaScript, it should be quicker these days. Can you render it as a PDF? Well, actually, Visualforce is very good at that, and Lightning isn't. You don't have an out-of-the-box tool for rendering Lightning components for supporting PDF output. Visualforce, easy peasy, lemon squeezy. Complexity. Well, Visualforce is actually, although you may not believe me, is actually a hell of a lot easier. It is quicker to do stuff in Visualforce than Lightning. But in Lightning, you have the benefit of reuse, which you do not get in Visualforce. So long-term, better to use a componentized framework. But out of the box, I did that thing just now in Visualforce. It took me about 5 minutes and about 10 lines of code. It would take me longer to do the same thing, probably, with a Lightning component. And what's this? Can be used to override standard buttons in Salesforce Classic. Well, that would be Visualforce. If you're in Classic, it's pretty much got to be Visualforce. If you want to use Lightning components in Classic, you need to use Visualforce, and you need to use a technology called Lightning Out to make that work. All right, so I'm not sure if I need to do a demo here. Shall I do a demo for you guys? Is this worth doing? Maybe just real quick to give you a look at some of the code. Let's just spend a few minutes on it to give you guys a feel for it. In my org here, I have some components. Custom components. These are they. I have two actually. I did the same thing. Two components, almost identical. One using Aura, this one using a Lightning Web component. And they're very dumb components. They just have an input field where I can type stuff in, and it echoes it back here, and I have a little button that tells me how many characters. So same thing here, same thing there. Okay. If I quickly compare those two, so I'm going to have to show you this in VS Code. So this is a project in VS Code. So here's the Aura component here. So that's what Aura component markup looks like. Okay, so I'll leave that open, and I'll show you the Lightning Web Component equivalent, which is that. Okay, so there's the HTML file for Lightning Web Component, and here's the equivalent for an Aura component. This is using, now the Aura one, this is using a proprietary markup. Okay, if you were a bog standard JavaScript developer and you saw that, you would freak out, because very little of it would make much sense. However, for this guy, this is much more standards-based. These are custom HTML elements. This is not using anything that's particularly proprietary. So this would actually look relatively familiar to somebody who's got little experience with Lightning Web Components. And that's one of the benefits of the new program. The JavaScript, this is the Aura version here. And this is the Lightning Web Component version here. Okay? So actually a little bit more for the Lightning Web Component. But again, if you look at this, this is the Lightning Web Component version. You've got a class file here. You've got class properties. You've got functions. This is something that's relatively easy to get your head around. There's nothing super proprietary in here. If I look at the Aura equivalent, it kind of looks like that. This is actually not a JavaScript file. It's a JSON file. Key value pair, that's the key, and the function is the value. We're kind of doing this kind of weird component.get and this v-dot kind of stuff. Again, that's not standard. So we've moved away from this proprietary programming model to a much more standards-based programming model. You know, quite a long course, so this is like 5 days to actually get your head around this. So if you want to know more, come and see me and we'll do some training together. It's kind of cool. Lightning Web Components, awesome. Actually really, really good. So I wanted to give you a quick flavor of that. I'm not going to go into any more detail. Hopefully I'm not sure what they're going to ask you about that in this certification, but I want to make sure that we actually can talk about both of those. You want to read up on it as much as you can. They're not going to ask you to go build these things. But a knowledge about both of them is certainly going to help. Also, their interoperability. One of the design features is that if you do have an existing Aura component, it can call a Lightning Web component. But you cannot do it the other way around. The Lightning Web components cannot call an Aura component. So there's a bunch of stuff like that that Trailhead is actually pretty good at touching on. All right, one chunky module to go, which is good because we only have 40 minutes left. Testing, debugging, deployment, that kind of stuff. Are you ready for this? So, Apex testing, we want to have a chat about that. They are going to ask you about that for sure in the test. This part of the exam is only 17%, but it's going to be an important one, I think. Use cases for anonymous code. I can talk about that briefly here. Things like the use of development tools, Salesforce DX, the Salesforce CLI developer console, touch briefly upon that. And a little bit about debugging. This is mostly around debug logs, actually, so there's not too much to say about that. So a brief knowledge of debug logs should see you through there. And again, looking at deployment, what are the options? Deploy, retrieve, push, pull, that kind of stuff. Again, not a massive amount in here. It's only 70% of the exam. If there's going to be questions, they hopefully will not be too involved. So let's just have a quick look at testing. So remember, if you write Apex code for whatever reason, you've got to test it. We force you to test it. Collectively, all the Apex code in your org needs to have at least 3/4 of itself has to be touched by a test class of some sort. Every trigger must have been called at least once by a test class. And it's all got to work without breaking. Okay, so no errors. That's the deal. So we give you this thing called the testing framework to help out here. So you've written some business logic that does something interesting for whatever reason. So the idea is you will write one or more test methods to evaluate that. The testing framework, is sensitive to those test methods in the test class, and it will run them for you when you ask it. And it will record the result of the test. And if it's successful, it will record the code, the percentage of code coverage for that trigger or that class, whatever the hell you're testing. So an Apex test method, this is what you have to write. You'll have usually more than one. Let's say you have a business class with a single business method in there. It's doing something interesting, whatever it is, don't really care. What you usually want to do is you want to evaluate all the paths of logic through your business method. Now, it's very simple. You might only need one test. But if it's anything complex, if it has switch statements or it has structured if then else, you want to go through all those paths. And usually you need different data sets to evaluate all the paths through your business logic, which usually means you have more than one test method. And usually it's like a one-to-many between business method and test method, because you want to validate your business method under all sorts of different scenarios. Also, you might want to validate it under good and bad data. How does it respond to dirty data? And most importantly, how does it respond to bulk data? When you write tests, you must write bulk tests, whatever else you do. How many records does bulk mean? Well, that's going to be down to you and whatever solution you're building. What's the anticipated throughput? What's it going to be like as it scales over the next 5 years, for example? But at a minimum, it must be more than 200 records. Remember this batching thing that we have going on? You see batching for SOCL, you saw it for triggers. You always test with more than 200 records if you're working in bulk, up to whatever value is appropriate for your solution. Now, test methods tend to conform to a distinct anatomy. They're in a test class. So test classes have an annotation like we see on line 1, at is test. Test classes are usually private. They don't have to be. It won't break if you make it public, but typically they're private. You give it a name. Again, a naming convention is good. If we can, we kind of have like business class name _ test, but that's purely a convention. In there will be one or more test methods, which are also identified using the same annotation. Again, they are usually private. They must be static. They must return nothing, must be void, and they must take no arguments. Again, you can call them whatever you like. Some sort of naming convention is probably not bad. Within there's usually a common pattern. All test methods pretty much look like this. They load test data, you do the test, whatever it is, and then you check the result. Did it work like I expected it to work? So they all pretty much conform to that, that structure. Now, it turns out, if I just jump back here, that the most onerous part of this, I don't know if you guys have had much experience with this, but is the load the test data bit. That tends to be the most painful part of the whole process here. It's important because by default, your test methods cannot see your real data, nor do you want them usually to see your real data. Test methods have to run in sandboxes, they might run in scratchals, they have to run in production, and they've all got to run consistently. We do not want usually your test methods to be dependent on the real data in your org. So they run with fake data, and that's what this load test data typically means. So, lots of ways we can do this, lots of ways you can structure these things. Common thing to do, don't have to, is to have a factory class, because you might have lots of test classes and lots of test methods, but maybe you want to keep all your sort of test data creation in one place. So having a class which just loads data, test data, not an uncommon thing to do. If you don't do that, make sure your factory class, you annotate it as is test, otherwise the system will mistake this for business logic. And this is the one time you would make this public, because in your actual test class, you'll make calls to these methods. You don't have to do this. It's quite a common thing to do if you've got a lot of test data, because it puts all that data creation in one place. You want to mess with it, you only have to go to one class to kind of fiddle around with that stuff. Excuse me. Then in your actual test class on the right-hand side, you can make calls to those factory methods, if you like. There's another trick you can do here, and that's to use a special method in your test class designated @testSetup. So if you use that, what you're doing, what the system will do is you put all your data creation into this @testSetup method. In your actual test methods, like on 10b and 13b here, that means you don't have to put your let's create test data stuff into those methods. The @testSetup will run automatically. The system will run that for you before your test methods run. If a test method screws around with the data here, any changes will be rolled back. So each of the probably many test methods in here will get its own clean set of data. So you don't have to do this, but it's quite a convenient mechanism, because it just means that your test classes, which can grow quite big, it helps you sort of mitigate the size of these things. You can only have one of these per test class. Now, the other thing to do is when you create data, yes, you can do a bunch of inserts, and that's fine. There's another way of doing it using a static resource file. So you can have your test data in comma delimited files. You can load those as static resources into your org, and then your test factory or your test, wherever you want to do it, you do test.load data. The S object you want to do, right, this is using a setup object called holiday, but it would work for account or course underscore C, and then the name of the static resource file that you gave it. So basically, this is quite convenient because it means your actual data is held not in code, but just in these comma delimited files. So if you want to change it, you're just changing a comma delimited file. You don't have to go and actually change the code in your test classes. It has another really cool trick if you're using static resource files, and that's when you work with relationships. You want to load related data. you think about it, if you were just, and then this little code snippet on the left-hand side here, if you wanted to load records into that structure, you would have to insert a bunch of course records, capture the IDs of each course record, and plug those IDs into the relationship fields for course deliveries, so that when you insert the course deliveries, you get the relationship forms correctly, which is not too bad to do if it's just a structure like that. But if you have a complex data model with lots of this stuff going on, it's a pain to do. If you're using static resource files, there's a sneaky thing that you can do. In your static resource file, in your comma delimited file, so let's say this is the parent one here, the course one, this top one, you've got a CSV file with name of the course and whatever other fields it needs. When you put a fake ID in there, you just make up a number, 1, 2, it'll do just fine. Now, when you insert that, when you do test.load data on that, it's pretty much going to ignore the ID, because it's going to end up, the records in there will be given a real Salesforce ID. But the sneaky thing is if you load child data using a comma delimited file, in the relationship field in the child, in the actual file, if you match up those fake IDs, so you've got primary key, foreign key going on here, if you match them up like that, when we do a test.load data on the child, it will replace those with the actual Salesforce ID. So it basically builds the relationship for you. And this is a real boon. You know, even if you're never going to do you don't do the cert, knowing about this is an absolute godsend, because it means you don't have to worry about bringing out the IDs and shoving them in there and getting it all to work. You just define this in common delimited files, you're done. It's really, really cool the way that actually works. I didn't believe this, by the way, when I first saw this, so I had to go away and test it, and actually it does work like that. But only in the testing framework. Don't get too excited. Now, test methods, like I say, they cannot see your real data. They cannot see any data for standard objects. They cannot see any data for custom objects. They can see setup data. So things like profiles and users and permission sets and roles and all that kind of stuff, that sort of thing is visible to test methods. They can't change any of it, but they can see it. If you want your test to see the real stuff, you use this annotation, see all data equals true, and you can do this at the class level, or you can do it actually at the method level. Either's good. So this does show the real data to your test methods. You still can't change any of it. You can never make any permanent data changes from test methods, never. But they can see the real stuff if they need to. There's 1 or 2 times when you have to do this. We don't like you doing this. It's not good practice, because it means if you do it, you know, the behavior of your test is going to be dependent on the order where you execute the test. So you may not get consistent behavior, because you will be moving these tests along with your Apex code when you deploy. 1 or 2 times when you have to do it. The only time that springs to mind is if you're working with currency conversion rates. You can't fake currency conversion rates. So you have to expose real data if you have a test, if you have code that relies on access to currency conversion rates. There might be other ones out there. It's the only one I have in my head. Then running the test, executing the blighter. So when you do that, you should always, and this is this bit here on lines 10 through 13, you should always wrap your actual test, whatever it is, inside these 2 method calls, test.start test and test.stop test. You don't have to do this. It won't fail if you do, but it's always a good practice to actually do this. And there are 2 reasons for this. Governor limits. Right? You want to validate that your code works inside the governor limits. It doesn't bash into a governor limit and fall over in a smoking ruin. So you want to test that. The problem you have in a test method is you have to load test data. So that is going to consume governor limits. And you don't want to be polluted by that in your actual test. So if you use this start test, stop test thing, then what goes on between those 2 gets its own set of governor limits, which means it's a fair test of your actual code. you get a fair chance, if you like, for the default set of governor limits. So if I actually ran that little example here, if you look at this test method, it's just dummy stuff. It's loading an account record. It's inserting a single account record. So if you remember that limits class, if you remember there's a pair of methods in here for every governor limit. So there's get limit DML statements and get DML statements. Get DML statement says how many DMLs have you done? So that will return 1. If I execute that same call between those two things in this test method, it will return a 0 because the governor limits will have been reset. If after the stop test I do that again, it's going to return 1. You kind of go back to the original thing. You can only do this once per test method, and only in a test method, by the way. There's another reason for this, and it's if you have any asynchronous apex. So if you have an app future method call. So an app future one, just real quick here, because I'm afraid of that time, is if I wrote some code. So let's say, I'll just do this in a text editor. Let's say I have a public class, oh, I should have used, this must be a good ball sign, weird, airing, trying to be too quick here, class, my class, like that. And in here, let's have a public method, let's make it static, void, my method. Okay, so my method does stuff. It doesn't matter what it does. I've got some stuff in there which it does things. Now, if I want to run that, I would normally do, because it's a static method, my class dot my method, like that. Okay, and that would execute that static method. But it does it synchronously. It will do it exactly at that point in time. If this was execute anonymous, it would run it there and then. Okay. But if I do this before the method name, app future, when I do that call, it won't run it straight away. It will be queued for execution at the end of the transaction after whatever commit happens, whenever the transaction ends. But at some point in the future, that method there will run, and it will run in its own transaction. It'll get its own set of governor limits. It'll run in its own transaction. It's actually quite a useful thing to do. If you're testing this code, you do not want to hang around for the server to get around to executing that, because it might happen at some point in the future. It's usually milliseconds, but it could be longer. So what stop test does is it forces the execution of any asynchronous code like that. So you know that at the end of that, everything has been run, including any asynchronous code that you might have written and might be testing. So I hope that makes sense. Checking the results. So this last bit in the test method, checking the result, we give you these assertions. There are 3 of them. Assert equals, assert not equals. And they're just there to make life easy for you. So for example here, assert equals takes some arguments. It takes an expected value, which can be anything, string, number, whatever. An actual value. So maybe this has been spat out by our test. If those match, life is good. But if expected value does not match actual value, it will throw an exception. It will fail. The test will break. And you would usually put an error message in there, which will be written to the log to tell whoever's running your test why this thing breaks. So assertions. One more bit's almost done here. When you do run your tests, you're usually an administrator, so you're a privileged user. So they will run under your user context. But if you've written code that's dependent on security and you want to run it under a non-privileged user, what you'll typically do in your test is you will find maybe from a profile a non-privileged user record, and you use this system.runAs block and shove that user in there. And you put your test inside test.stop test and stop test. inside there, and it will run under that user context. So again, it's a fair chance of testing how does it behave under a non-privileged user, system.run as. And finally, code coverage. Remember, we have to create code coverage. The calculation is performed when you run the test. If the test is successful, the server will record it and will tag your class with the code coverage. And it does it kind of sensibly, so it doesn't include comments. It doesn't include sort of closing curly braces. It doesn't include any system.debug stuff that you've left in there. It is going to include everything else. So remember, we were looking for a minimum of 75%. The reality is it should be up in the high 90s. Often difficult to get 100%, because you might put all sorts of error handling in there, and it's often difficult to generate all the errors that you might, potentially be guarding against. Okay, enough about testing. Debugging. This is about debug logs. I'm going to be very quick here. Hopefully you're familiar with this. You can control the verbosity of your debug logs in Developer Console or through the debug log page in Setup. It's usually done by category. These are the categories, and you basically control the verbosity. You just have to be careful that you don't make it too verbose, because there is a limit to the maximum size of a debug log, which I think has actually been increased to 20 megabytes. So it's a bit bigger than it used to be. It used to be 2. But you basically control the verbosity by category. I'm not going to dwell upon this. And I want to finish off by talking a little about deployment. You will be expected to know about sandboxes, how to create them, what the various sandboxes do. But you cannot write code directly in real production systems. You must author code in a sandbox, test it, deploy into production along with any tests, and those tests must run in production successfully. If it's a trial production system, that's no longer true, but a real production system you can't code in here. You can make declarative changes in here, but you shouldn't. You should always go through a sandbox. There's an expectation that you will know the 4 sandbox types and their use cases. This is definitely something they love to ask in the exam. So make sure you are aware of these 4 guys in here. Full sandbox, partial, their characteristics. So storage limits, a refresh interval, things like if you're going to do performance testing, you'll probably want to use a full sandbox to do that, because you want a large amount of data, for example. They may ask you about SFDX. They mention this in the exam guide. So don't have time, we only have 15 minutes left, to go mad about Salesforce DX. I think it was available again a couple of years ago. It's designed to help with things like team collaboration and working with source control systems like GitHub and the likes of that, to support things like continuous integration and delivery. So it can be quite a really complex topic. The idea behind it, though, is that it is fairly agnostic about the tools that you as a customer might use. So whatever development tool you use, be that Visual Studio Code, which is the one that we support now, or other ones like IntelliJ with Illuminated Cloud, or any of the other guys, different version control systems, different build, test, and deploy tools. It'll work with all of them. It's command line driven. It's designed to be agnostic about all of this kind of stuff. It uses, if you use its full power, it uses something called a scratch org. Again, I'm not sure how much they are going to want to talk about this with you guys. Scratch orgs are environments that you create. You design them, you spin them up. They have a maximum lifetime of 30 days. So the idea might be, if you're going to use a scratch org for development as opposed to a regular sandbox, is you need something called a dev hub. A dev hub org is just an org that records the number of scratch orgs that you have. It's usually your production system. It has no harm if you use production to do this, but its only job in the world is to sort of monitor the number of scratch orgs that you might create, because there is a limit. So if you were going to build a development environment that used SFDX and scratch orgs, you have to have a dev hub. Okay? You will probably have some sort of version control system, let's say Git. You have an IDE, let's say VS Code. Okay? you would use the Salesforce DX CLI to connect the Dev Hub and then create a scratch org on your own design. So usually your scratch orgs, you control what they look like. It's called an org shape. And you would usually try and design it to match your production system. So you use the CLI to create that kind of stuff. And then you start creating code. You might create Lightning Web Components. And you would push those to your scratch org, not deploy, but push. If you write any changes in the scratch org, you pull those changes down to your project, your IDE, not retrieve, but a pull. The difference between push-pull and deploy-retrieve is that push-pull is sensitive to delta changes. It figures out what's changed at either end and only brings down or moves up the changes. And it will also resolve dependencies for you. If you're doing a deploy-retrieve, which you're probably used to, you have to say explicitly what to deploy or retrieve. You will work on code in your working directory, and you will, I have that in here, you'll make a change to your code, you'll test it, you'll stage it, you'll commit it, you may even send it to the remote repository. When you test your code, you will push it to a scratch org, test it, you make a change to your scratch org, you will pull those changes back down here. So any changes you make, not just to code, but to any metadata, is stored in a project file on your PC or your Mac, your working directory, and then that is staged and committed to version control. When you're happy and you're done, then you might start thinking about, well, I need to deploy this to my sandbox. I need to go into my normal sort of application development lifecycle, and then it will ultimately into production. So a couple of summaries about the different developer tools. Because of time, I think I'm going to have to go through this pretty quick. So pretty much you can do most things now with an IDE like VS Code and Salesforce DX. Notably, Lightning components, just be careful. You can create and work with Aura-based Lightning components in the developer console, but not with Lightning Web Components. If you're going to work with Lightning Web Components, developer console does not support it. You must use an IDE to do that. Okay? Otherwise, you can author all sorts of other codes in all of these tools, Visualforce pages. You can execute anonymous code in developer console, all the IDEs. You can look at debug logs, you can run tests, you can run queries. You know, they're very, very flexible. Creating sandboxes, you still need to do that through the setup menu. Creating scratch orgs, that's done through the SFDX and CLI. Deployment-wise, again, change sets, yes, but we can deploy using SFDX or the Ants migration tool. So there's going to be an expectation that you are comfortable with the capabilities of these deployment tools here. Running out of time, so I'm not going to go through this in super detail here for you guys. Deployment considerations, I think I've probably said most of this. So I'm really concerned about, so I'm going to have to skip this without going through in detail. I'm sorry, that's because we are close to the end, and I want to make sure you have time to get the voucher code, which is the really important bit. So that's, God, my voice is starting to go. We've been going for nearly 5 hours now. So certification preparation. So what else? Where else do you look? Well, of course, Trailhead, of course. Trail mixes. There is a Trail mix for Platform Developer 1. There's also a trail called Study for the Platform Developer 1 exam. So you can just find these with searches. I didn't put the links in here. Other certification days are also available to you. That link down there, bottom right, will tell you what other certification days are scheduled. So if you didn't like me doing this one, you want to hear it all again, you can actually register again, I guess, if you like. Because they're running all the time, all around the world, different time zones. Trailhead Live, I've referenced it a few times. So myself and my colleagues, we're all doing stuff on Trailhead Live. I've done a couple on triggers. I've done one on security summary. One of my colleagues has done a really good one on the save order execution, Andres Perez. I'm doing one later in the week on testing and a couple more next week. So this thing is evolving quite rapidly. So they're usually fairly short, half an hour or so. So they're actually quite a good resource, and that's actually evolving almost as we speak. So here's the good stuff, guys. I'm pretty much done. Thank you for your attention. This is your voucher code here, that great big long red thing. You need to write this down, I'm afraid.